AA. Okay. Welcome, welcome. I'm gonna show you something here. Let me bring up this thing here so you can see usages and everything. And let's go over here. And I will open up some kind of runic file. It will spawn up runic LSP somewhere. Maybe not. Yes. Okay. I thought for sure it was gonna show up here. So basically, I checked the processes because it was like lagging a lot, and I had two roaming like runic LSP processes that took up like 100% of CPU. So there's something weird going on there. Right now it looks fine, but I guess maybe it was like from way long ago or something. They just, now it seems fine, I guess. Yeah, and it works. So okay, cool. All right. So I've been doing stuff. I continued working on the scope stuff. Modules now work, I'm pretty sure. Let me actually check this again. I have this module test file, and then the a module file again. Yo Blue, welcome. How's it going? And so if we now test, we run this module test, it should work. Yes, it works. Okay, so basically we import this module. This is the module, so this is module RN. Oh, I saw the LSP crash there. And this is module test RN. Did it mess something up? I don't know. And then yeah, so that's module test RN. This is module RN. And yeah, we define this function on module RN, and then we run it as well. But the output that isn't shown, even though we import the file here, it actually does run this command, but the result is actually stored in the module variable, which is how the behavior works right now. If you bind some execution to a variable, it will get stored in there instead of being, you know, forwarded to standard out. So then we can also run this function, and it will actually run the function. So it all works properly now, and I've fixed all the I need to save the file first, and I fixed all the leaks and everything there. So yeah, now the module does work again, and you can access the functions and everything. Also, I improved the error messages a little bit. So if I try to run a command called ASDF or something, it now says properly here the command ASDF not found, which is really helpful instead of just getting this file not found error, which is kind of weird. You know, you never know what it is. Also, I added this, so if you misspell a member access, now it says like mode not found in module, and then it shows the type of the kind of value here, which is, it says scope here right now, but I'm gonna maybe change this to be like a module instead. Now it's just like a scope that you can access things on. But yeah, so a little bit of just helpful improvements there, just to it helps also when you're like making the language as well, when you like try to debug things that go wrong. All right. And I believe when I ran this, I think I got some kind of leak though, or something went wrong anyways. So we import the module. I don't think we do anything with this module here. Let's just not do that and see if this file runs for... Okay, yeah, so this one actually runs good as well, and then we'll just try importing this as well. Okay, now we get a leak. Interesting. That's weird. I mean, we didn't get a leak in the other file, but for some reason we get a leak now. Oh, I see. There's an error, and then we don't like clean up after ourselves. So there's an invalid ref error here. Okay. That's also interesting. Why would we get it now and not before? Because I don't see any like usage of this. Hello, Penguin. Welcome. If you get a chance to become superhero, will you become Green Lantern because he can create stuff with his imagination, willpower, just like a programmer? Yeah, but then I am already a superhero. I don't know. That's such a. I think I've never really thought about that. But yeah, I guess. I mean, yeah. Maybe something with time, like being able to increase the number of hours in the day or something, so you can get more stuff done every day. Okay, invalid ref. Interesting. So yeah, let's turn on debugging mode. I will go to RC. Turn on this. I've also improved the messages a little bit here, or yeah, increased them a little bit. So we've got that, and now we'll do runic log executor. Alright, so apparently we have some kind of invalid ref, and then we got a bunch of leaks. Now what I'm actually interested in what these leaks are, because we don't want to get a bunch of leaks if we get this weird error either. So this is like an RC, because if we get a script execution error, we should just be able to deinitialize everything and not have any leaks. So it's kind of weird that we get leaks here. It's a list of scope stack. Oh, it's bindings. I see. It's the actual RC that leaks. Invalid ref. And it basically also like, it's like when we try to initialize this thing, and then we get an invalid ref. Interesting. So we're trying to create. I'm not sure if this invalid ref is related to this, even it comes right after. Array list of bindings. I mean, that's, yeah, we're just pushing forward context. Closure from interpreter scope. Okay, let's check out the closure function. So yeah, I changed this to be a ref now instead as well. Maybe power to clone yourself, you can work in parallel. Yeah, maybe, but then I don't know, I want the experience as well. Like, I want to experience the whole development. I want to feel like I made it. I don't know, like I made, or well, learn from the experience and also experience the experience. All right, we call in closure. Call in closure from this. And yeah, it just manages to push the forward context. Let's see what else we have. We have a forward context which we push or pop. We have something that we popped, pop. So it should be over here. Push frame. No, that's another one now. Oh, that's a detach. Yeah, so the detach is used for modules. So basically execute the module and then we detach that scope so it's like separate. And then we should be back at, because normally we have 3 items in the context. Here is like the beginning. So basically init with runner is like the start of the program. And we get a forward context and a singles. That's the normal bindings frame. And that, so apparently this fails to be copied. And we got the forward context again because of how this is like structured. And here we are now a forward context again because we're evaluating an import expression, I believe. Execute, or no, it's a binding, right? What's a closure? So closure is basically like when you define a function and you want the function that goes here. You define a function and you want the function, so this is a function definition, and you want the function to have access to the scope that is like outside of the function. So if I, for example, have like a variable, my string, this is my string. If I want to have access to this variable from inside this function, I have to, and I don't like have to pass it in, I just have access to it. That's done with what's called a closure. But it's, and basically what it is you just take the scope from outside and provide it with the function reference, so that a function reference is basically this, the function here, but also the scope outside. And now we can have access to this as well, like from inside the function. So we could say my string. If we didn't have closures, then the function wouldn't know where to get this from. The closure is basically attaching the outer scope to the function itself, so you can access it. When you return a function using a function. No, it can be any function definition. It's like if you have a scope with potential bindings like this. This is a binding. We're binding the identifier my string to this value. So in the scope of the file, this is a string identifier. But the function, you can pass the function to something else, some other module that doesn't know about my string, for example. And when you call module function from the other file, it wouldn't know how to pass in like my string, let's say. But a closure will allow you to do that because it will capture the outer scope with the function, like when the function is used somewhere else, you actually bring the closure with it so that it can access that scope as well. I guess it's kind of hard to see when you don't actually see the structure of it. But basically, if we go and look at the function reference type here, you can see that basically we have the function declaration. That includes the type of the the name of the function, some other information parameters, return type, the function body, which has all the statements, all the expressions inside that's required to run the function, and then we also have like the closure here. So we just bring this with the function reference, and then we have the scope from outside. So yeah, all right, you got it good. Okay, but for some reason this fails trying to push the frame here, but it fails even before that. I think it fails when trying to get the ref actually, or doing this. I think it's failing here. But then we should get this error now. Which I think we are. Yes. Well, okay, we get the error somewhere. Debug ref invalid ref. Where is this coming from? Is it this? Why do I not get color? Hello Polaris. Welcome back. My friend is currently forcing me to code in Scratch with him. I mean, that's also coding. It can be fun. It's you know, I think graphical programming, or whatever you want to call it, like I think it does has its place because it. I mean, you can feel like it's not. It's not text based, so you don't have like the usual kind of tools and stuff. But it is kind of nice sometimes to see like the code in diagram. Sometimes it's like easier to kind of see what's happening and maybe reason about it. But yeah, what kind of coding do you are you just learning it or? Because for example, Unreal Engine actually has a graphical programming called Blueprint, which I tried, which is really nice actually. But I think that's a little bit different than Scratch. Also, there is a, I think, game engine or game maker equivalent called Construct, which also uses kind of the same like Scratch, I think. Like you connect different components together to make stuff happen. Visual scripting, yeah. I mean, yeah, visual programming basically. That's why I said like graphical programming or visual programming, or yeah, where you actually see the things and you can use a UI to create the components and everything. And it could be a nice introduction to programming. I think Scratch is mainly used for maybe to teach children. I think was the idea. Teach children programming, which is a really cool idea. Like to have the graphical thing. Why is this not though? This is not like red though. Begin color red. End color. I'm pretty sure this is the place where it happens. I'm just gonna add something else here to see if that's the case. Yes, it is. Okay, so why is it not red? This is so important. Maybe it's because it's like log debug or something. I have no idea. Everything else seems to work. Anyway, we know that it comes from here now, so yeah, it's when we try to get a new ref. Where did the scope go? Oh, it is here. The binding ref. Oh, because it's a constant. Okay, I think what we're gonna do is we're just gonna do we just return the original? No. We have to clone it, I guess. Yeah, okay, let's just clone it. Why would we get this now, though? There's something different with the code that makes it... Not sure. Maybe it's when we call this. I don't know. Anyway, let's just support this here by doing well, we could implement clone, but well, okay, yeah, sure, clone or C clone. Do we get a reference, or do you need to be? Ah, you need to be a thing there. So okay, sure. Then this will be binding value. Also, there's no colon there. So let's return name. Dupe. And I think this is and then value is value clone. All right, there we go. Wait, we need allocator. Okay. And then it's not really ref, but whatever. It's a constant, so we'll clone it for now. It's gonna get cleaned up. It's not optimized, but whatever. By the way, using ANSI code for colors, yes. It's so easy to. Once you've learned it, it's like a super easy thing to have. Do soldering transistors together considered as visual scripting? No. If you that would be like physical programming. I don't know. It's not really programming though, in the same sense. It's programming is like strictly for software. Or well, what if you can, like, you have like a giant computer then that you turn a bunch of knobs to make it change its program, but you actually change the hardware. I guess that could be considered programming. I don't know. I always use type color instead of color. I'm not even British. I use ANSI code too. Yeah, I don't know what you could use otherwise. There's probably other ways maybe to do it. I don't know actually. I just know that it works with ANSI. Member function expected to. Oh yeah, so you want an allocator. Okay, good, because we have one. Actually, we could check there if it's a constant. We can clone it. We can like do it here, but whatever. Does not support initialization syntax. What? Oh, right. We need to create the pointer. Right. Allocator create, binding value, turn pointer equals. There we go. Okay, now you are like that, I think. Okay. End of errors. There we go. Now it works. Yeah, I wanted to get ahead a little bit and fix all the issues before we can move on to implement more features. So there we go. We can see everything works in this file. So pretty cool. Yeah. Yeah, so let's see what else is on the agenda. We have a bunch of stuff that we want to have. Actually, I want to try recursive functions because I did add the function def to the closure now. So potentially it could call itself. I'm not sure how it's gonna work with like the scopes and everything, but I guess we'll find out. Blocks as another function, exit, return to it. Yeah, that's still design. I'm still thinking about the design of the language. So yeah, there's especially with like, you know, the pipelines, of course, is like the main building block or whatever of the language. The runic functions themselves, runic files as functions or modules. There are a bunch of stuff to think about there. If you simulate transistor on screen and put it together, but then it's just a simulator. But if you simulate a programmer, that I guess that's what the AI is doing. We're simulating a programmer. All right, yeah, we have LSP if we want to work on that. Let's see, streaming. Yeah, we do have streaming now. So we don't have this, but we do have streaming, but we don't only output. Streaming input. We don't have streaming input. We also only for one stage pipelines, which is not really a pipeline, but I'm calling it a pipeline anyway. We don't have streaming output for pipelines between pipeline stages. So we do not have this. We don't. Okay, so able to forward output into outer context from. So this one is done. This one we nuke because we don't need that anymore. I should also clean the bridge up actually. If I don't already have done that, I don't remember. Create a new context when binding identifiers. Yes, we are doing that. Explore an idea of creating a context tag we can push. Yeah, so this one is already. Yeah, this is done. Everything here is done. So, but we do not. I will do this streaming input and output, and we'll put this in a sub list. So now we have, yeah, streaming output, but only for one stage pipeline. So we do have this, which is really nice. Whoops. We don't have streaming input. We don't have between pipeline stages, which is going to require a little bit of change with how the stages are created and everything and set up. That's going to be a little bit involved. So I probably won't tackle that today. Maybe add a stream, but it will be very useful because right now you basically can't have, basically pipelines are broken right now. which is bad. But yeah, there are other things to fix as well. And the input is not. So basically, we need to fix the pipelines right now. We need to implement these things. Yeah. Now I want to add also functions. I want to add like modules. So import modules is done. We can bind module to identifier. Execute statements in module when ported is also happening. Now we cannot use output of module execution, but I think that these two will kind of be. This is kind of interesting because this plays into a little bit of the design of the language, which is not 100% yet. So this will probably change. I think the direction that I'm gonna go for is that I want to treat every runic file as a function. And a function is basically the same as an executable, except it has statically typed standard in, standard out, and arguments. And exit code can be also like not just a byte, but some kind of data structure as well. So that is the difference. It's basically it has standard in. It's an executable, so it has standard in, has standard out, except it's like typed. So the way I'm thinking about this is not that we kind of import modules. We run runic as functions, runic files as functions. So they are like executables. But then it's like, okay, but then you would still want to have like importing libraries. How do we deal with that? So that is what I need to figure out. And I think I know how to do that, because I want to introduce being able to reference things as well as execute them. So right now, when you just have the function right there, or if you even do like this, you actually execute the function. This is not a function reference, this is executing the function. But I think I want to introduce a syntax like this. So you normally, this would mean reference. So you would reference the function, which means we don't execute it, we just set result to be referencing the function. So, and that's how normally in programming languages, if you don't have, you know, this, you don't call it like this, it's just a reference. But if you do this, you call it. But here's like the other way around. Basically, you do this, you actually call the function. But if you do this, you reference the function. And that could be same for modules. So basically modules, you can do this to kind of reference the module. We'll see how this works, but you would probably do something like this and then reference this to import the functions. But then you can also call these as functions as well. And what I'm thinking there is that you would kind of have a top definition of, like a top scope definition of the function of the file. So you would do something like this, like you have a function, and then let's say this takes a string, and then you have at, which denotes that you're talking about this, the top file, like this function, the scope refactoring file, the function that the file that you're in. And then you can have any kind of arguments in here, and then we have the output of the standard out here, and then yeah, and that's it. So this would be the signature of the file now, and you would have it like at the top of the file to show like what file it is. If you don't have, okay, so if you have this, now we know that, okay, this function, from standard in, it takes a string, it doesn't have any arguments, and then standard out, it just produces a string. And so let's say this module.rn has defined this. We would know that it has this, let's say this is in module.rn. So then we can actually like type this to something else. It's just like executing and it's running a function or executing executable. We will be able to, you know, echo some kind of string into the import, and then also you do something with the output or something like that. So that is what I'm thinking, like you can run the runic files as functions, but I'm not sure about the import keyword. But yeah, this is the way that I want to go. Basically all the runic files will be functions that you can call, and you can specify the type of the file like this. But if you omit it, it will try to infer the type of the depending on the usage of what you're using, like the standard in, the standard out. It can be inferred from that. So basically, if you connect standard in to you know, parse int, which takes a string, let's say, then we would know that, okay, standard in should be a string. And of course, if you try to put standard in into I don't know, add 5, that takes an integer, it will, you know, if you try to do both string and integer, I'm not sure if we're gonna have like some types, but it's basically gonna be, you know, an error probably if you do this. Then if you try to infer the type, it depends on the type system how well we can handle that. But and then you would also have like standard out, or I'm not sure exactly about the syntax is gonna be, but you know, if you do something like this, this would just be inferred, like, and the default will be string, I guess. So this would actually then be, I mean, this would just be equivalent to wait, how do you refer to standard in a bash file? Actually, I don't know that. Like the standard in from the bash actual file. But this would be, but if you only have this this code in your runic, so that would basically be cat here, almost like this would be the basic cat executable. You just put whatever comes in standard in, you put into standard out, basically. But it doesn't, of course, it doesn't have any, you know, you can, it doesn't take files into account if you put files in the arguments. It doesn't have any arguments, but have you ever wondered why Polaris is 2098 in their name? Maybe they are from the future and just witnessing the history of greatest program. Yeah, I don't know. It didn't used to be that. It used to be Polaris 7. I'm not sure if you have like a new account, or if YouTube did something weird. I'm not sure. Have you sold AOC since? I haven't actually done AOC. Maybe we can try to solve in Runic. I forgot about. Okay, let's go to. We should have this here. So here was that. Actually, do we have mod? Also, did I fix this error? Yes, I did fix it. So if we echo 3 mod 2. Okay, so we do have mod. Yo, Zevlins. Alright, no problem. Welcome. So maybe we can actually do Advent of Code, like the first one, maybe. I don't know, actually. We don't. Okay, so the issue also is that the pipes are broken right now, so you cannot have like echo hello into cat, for example, because the streaming output only works for like the first one. So yeah, I would have to like revisit this later. So I don't think we can actually do that. But I wanted to just jot down some stuff in it to do here. Alright, so modules are, you can bind modules to identifier. We also have member access on modules that we do have. Now we don't have the pub keyword for accessible bindings. So we don't have the pub keyword, but I do want to introduce it, I think. So you can have like local functions and then you say that, okay, this should be public. Yeah, this one standard in like special identifier or special binding. We don't have this. We do not have typed pipes, but I guess that comes more. Well, actually, we should start thinking about typed pipes if we want. Yeah, if we want to support functions being able to output like values. Otherwise, we have to like stringify everything. So yeah, that's gonna happen there. And then we should also have some kind of standard out. Now I'm not sure how this would work, like, because in Bash you would type something like, you know, echo and then out to wait, no, it's just gonna be like echo hello. Let's say that goes to standard out, and then if you have a function, normally everything goes to standard out, of course, and that's the case here as well. Actually, where would you use standard out? Because everything would normally go to standard out. And if you have a string, you can just echo the string or printf the string. No, let's skip that standard out special binding. Standard in we need though. So standard in you would do something like, yeah, if we get standard in and then you pipe it to echo or something. Or cat, which is basically just cat, or yeah. Or I guess just standard in. I guess this would kind of be a function then. It's like a function that you call that will output whatever comes in from standard in. So this would be the this would be the equivalent of the most basic cat program, I guess. Standard in cat, you know, something like that. Expressions. So I also want to add binding or value references. So this would be like const my function equals another or module dot some function, but then we have a reference there. So this one would like, because if you don't have reference, it would just call some function and put the result here. If you have an ampersand, it will denote this as a reference. Oh yeah, also, yeah, I just had also a kind of a revelation with this whole thing. So executables are gonna get a little bit of treatment here, because right now if you just try to run anything like this, this will be like valid code and valid semantics and everything. But when we try to run it, of course it's gonna fail. Command ASDF not found. Now what I'm thinking that I want to have is explicit definition of which executables you want to be able to access in the file. Now I'm not entirely certain of this, but I think that would be a cool thing to have because of you know, a little bit safety to ensure that when you're like referring to some identifier, you will actually be 100% sure that it exists in the scope of where you want to execute it. So you're not trying to execute an executable that you didn't know about. Let's say you misspelled or something, and then you execute some other executable which you don't know what it's gonna do. So I'm thinking something like this. So bear with me here. I have a couple of ideas and a couple of new constructs that's gonna help us do this efficiently. So if you just do this, this is gonna refer to the identifier ASDF, and if it's not in scope, there's gonna be an error. However, if you do this, bang identifier, now that is gonna be referring to the command ASDF. So you're trying to run the command ASDF, or for example, you know, echo, for example here. Is echo actually like a special thing? Because yeah, I'm not sure about that. It shouldn't get blue like that. But this will be is something to do with the highlighting thing. I need to fix that. So this will call echo. Okay. I haven't done this yet, but this is how I want it to be. Now, what you could do also to not having to type at echo is that, because the idea is that, okay, now we know that we're trying to execute an actual command. And so also if you have something that is like bound to echo, you wouldn't refer to the bound variable as well if you use this here. But you can also do this if we implement referencing. So you can do like const echo equals reference the echo command. So now echo is bound to the reference of this executable, which means that you can execute it just as before. So this would be one way of like getting around if you if you don't want to have like banks everywhere. Another way that I thought about was that in the context of a binding where you put the variable, because in a binding first you have const or var, which denotes if it's constant or mutable, and then you have the identifier. So this always has to be an identifier, right? Or it can be a destructuring as well, but let's focus on the identifier for now. If you have a special syntax like bang here, echo, this could be a shorthand for this. We can make this into a shorthand for this thing here. So this would like say that, hey, we're binding the same name echo here with bang to an identifier with the same name that is bound to the command, to the reference of the command. So because we are in like an identifier context, we don't really execute the function. We just you know, it's a special syntax for more quickly defining which which executables you want to be able to access in this thing. But you can also do this just if you don't want to have to do that as well. But just to try and just to make it both more safe and also but also like some kind of compromise so that it's more easy to define these things. So it is a little bit, you have to add the command. Otherwise it is gonna, if you're trying to use like a command that you don't have and you're like, okay, this doesn't work, but then you're just gonna get unknown identifier or something like that. And also it will show up like in the LSP, because we're gonna have like semantic analysis and we're gonna see that, okay, well, this isn't in scope. So yeah, so that's it. I think we can have semantic analysis anyway on that. Yeah, you should be able to have that. I haven't thought about how that would work actually, because then you would have to kind of do some kind of running of the statements to like declare bindings in the scopes. You would have a kind of a scopy thing, and then you would have to, because that's happening only in the executor right now. But yeah, basically when all that is done, it should be possible. Then this is going to get complained in the actual thing, and we can even have a code action to actually automatically define the thing for you. Can you print hello world using Zig but not on a console on paper using printer and memory map IO? Memory map IO? I mean, probably. I mean, yeah, but I can't do it because I don't know how. But you can do. I mean, yeah. I can't personally, but I know it's possible. But yeah, so this is what I'm thinking here. And it's also like, the reference thing, I think is going to be useful not only for this, but also for referencing like functions without executing them, so you can kind of alias functions or whatever and stuff like that. So yeah. And also I thought about this also, like if you have like, you can have partial as well. So let's say you do this echo with greeting, let's say. Actually, should this be camel case or snake case? Because it's a function. So let's make it camel case, I guess. Echo with greeting. Now, if we set this to a reference of this expression, what I'm thinking is this is actually partial application. So basically, it's gonna bind to calling a function that calls execute, or I mean that executes hello, or echo with this first argument hello, and then if you try to use this, you would get hello as like the initial argument, and you can add another argument here. So this would be pretty cool as well. It would be kind of built in to the whole reference package, and yeah, it would be pretty easy. I mean, we just need to kind of make this into a function, really, that will just have this as its kind of, it's kind of like doing a very shorthand well, it is partial application actually. So we have to take the function into account. So let's say you have another function that's called like add5 or add, let's say. And this takes, let's say we don't take anything in to standard in, but we do take 2 integers in the arguments. So let's say like x and y, and then we return an integer. Okay, and then this just returns, you know, x plus y. And then you create add5, which we reference to add5. So this basically creates a new function which has this argument already consumed in the 5 here, and then you will get a new function that takes 1 integer now as an argument and does this. So this is basically going to be like a function, a new function that will, yeah, I'm just repeating what I said. Yeah, so it's like partial application. This kind of stuff, interviews ask for unpaid internship here. What? Really? Or are you talking about what I'm talking about, or what you just said before about using a printer and memory map IO? Because that's insane if you got that question. All right, so that's a little bit of functional things there, but I do like it. We're gonna mix and match what we like. Oh yeah, also I want to add, oh yeah, so let me write this down now. Explicit command syntax. So echo hello, runs echo with argument hello. So that is one example, and then we also have const echo equals reference to echo, defines identifier or binds echo to echo command, and then the shorthand syntax for above statement or expression. Statement, whatever. Yes, I'm pretty sure this is what's gonna happen. Insane question. Wow, yeah, that doesn't, yeah, it doesn't sound real, but if it is, that is crazy. That is crazy. Like, you're an intern, so you should be like the noobiest of noobs coming to try to learn stuff. So it's like, what the hell? Okay. Okay. That is what's gonna be there. All executables except for like runic functions have, or okay, all executables can be thought of as runic functions with the signature function string, and then exec name. Arguments is a variadic argument of strings, which means it can take any number of arguments and every argument is a string. and the output is a string. That is the signature, the runic signature of the function that defines like every executable, because we don't know what they will put out. It's just a string of bytes, and they accept a string of bytes, and they have a name, and then that's the only thing we know what the name is, and then there's a variadic number of arguments there. So yeah, once we have the typed functions and stuff, everything in place, then this would be the signature of executable. So that we know already, which is kind of cool. But then runic functions will have the ability to change these types and have actually strong types there. Maybe we just want to flex this knowledge. That sounds plausible. Okay. Yeah, was it anything else that I wanted to... Yeah, so trying to call a command as an identifier that is not bound will result in unknown identifier error. All right. That is what I want. Now let's see, expressions. Also, I want to have pattern matching. And what I'm thinking here is basically we're gonna have maybe not switch, because switch implies that it's actually not pattern matching. It's more like yeah, you're matching, you are matching, but you're matching against a complete value. Is usually what you find with switch, but then in other languages you can have things that's like match or case, and I'm not sure exactly how I want this to work, but I do know that I want to have some kind of pattern matching feature, and we're gonna have some kind of pattern matching maybe interface that is gonna work with different kinds of types. So we are gonna have for example regex patterns, like built-in regex patterns that is gonna be able to be used as pattern matching against strings, for example. I'm thinking also maybe glob patterns as well, which will automatically work with like the file system, just because it's so useful in scripts to be able to use that. That's the plan, and basically how we're then gonna use this is that there's gonna be some kind of pattern matching syntax, which basically will result in a bool. So let's say we have pattern matching syntax or expression. So basically I'm gonna make a new thing here. So let's say we have like so let's say we have some kind of regex here. We don't really have this. I'm gonna use like the JavaScript syntax for now. I'm not sure exactly how it's gonna be, but let's say we have some kind of regex here that checks for, I don't know, is number, so number pattern or something like that. So yeah, just something super basic there. Okay, so that is the thing there. Whoops, what the hell? Okay, now so that's the pattern, and then we have some kind of input string, which is gonna be, you know, some kind of number, let's say. Whoops, we don't have this there. And then how we're going to use it is that you are going to say result, or basically you can do an if and then input string, and then we could have maybe like a binary operation, like a binary operator. I'm not exactly sure how it's gonna be, but it could be some, I'm not sure exactly, but some kind of operator. Actually, I mean, we could pipe it. We could pipe it into the number pattern. So the number pattern is just a function that takes a string and returns us a bool. Yeah. Okay, let's just go with that for now. And then, you know, that's how you match on the thing. But of course, so then here, like input string matched number pattern. So that's just a basic idea. Maybe we were gonna have something like match or case or something. Maybe case, because that's more like bash-like, I guess. Case, and then you would have like case input string, and then we would have maybe like or match, maybe. I'm not sure actually. Wait, do we have match and case in bash actually? I'm not sure. Let's do match, let's say. So match input string, and then you have like number pattern, or you can have, and then that this would be one case, or you can have like this, you know, directly in here. Something like this, you know, or if you even do like I for lower, like case insensitive. Wait, what am I doing here? Oh yeah, so that is 0 to 9 there. So we'd have one of these and then some of these. And that would be another case there. So you could have something like this, where this is like, but this, I feel like this is so specialized for matching, so I'm not sure. It's like, it feels like this is just a fancy if, you know. But I guess it could be such a common thing that you might want to have it, because it's like a better switch, basically. It feels like. So this could be, and then this expression here could be, then it could be a pattern. So which would be basically just a function that takes the string and outputs a boolean. Or I guess it could also be the same type as the thing itself. So this could be like 451. If it matches this exact value, you could also put it like this. Yeah. So basically, yeah, this is what I want to add as well. And then let's say you want a glob as well. Like let's say you have like a file pattern is, I'm not sure exactly about the syntax here, but basically, what if we just say glob as a built-in, I don't know if it's going to be like a built-in function or whatever, but you're going to have to denote it somehow, because if it's just a string like this, we don't know if it's like a glob or something. You know, you have to kind of say it's a glob, and that will produce kind of the glob sort of pattern thing that you need, right? Because otherwise this would be the literal string of star slash star dot star. This would be the actual glob pattern. So then here, either you pass this you know, directly as an expression, or you just say file pattern. Yeah, so this is how I want it to be. Yeah. And I'm not sure about the name here. Match seems like a better name. However, I believe there is such a thing as case in Bash, but I'm not exactly 100% sure how that works. All right, what else did I want to put down here? Let me check my notes here actually, because I wrote it down. So we have case pattern matching, glob patterns. Oh yeah, I was thinking also like standard lib, special import. I'm gonna put standard lib here. Standard lib special import, because the idea is that if you would have Runic, then you would have installed the Runic executables somehow, and then that would be able to provide the standard library by itself. It could be built into the actual, you know, executable, or it could be available on the file system, which is great, I think, because then anyone could go and look at this, what the standard, just like Zig, you would be able to go to the standard library and actually check directly what the code is doing, which is really nice. So yeah, I think standard lib is going to be stored on file system with a special import. So just import module name standard, so you don't have to specify Runic like .rm. You would just specify standard, just like in Zig, and you will get access to all the standard functions and modules and everything stored on file system together with oops, I almost said Zig there, Runic executable or whatever. Yeah, just stored on file system so that you can access the source code through the LSP as well. So really cool there. And then we can you know, provide all sorts of nice functionalities that you would be able to use. Yeah, and I have had a whole bunch of ideas around how to deal with the command situation, which we talked about. Let's see, Runic type streaming. Oh yeah, I was also thinking about this. So when we have pipelines, for example, or this is really not part of pipelines, I guess. This is more like expressions, maybe. Let's add it down here. Pattern matching, yeah. So this would be a new thing. So this would be like, so what I'm thinking here is, yeah, typed. So basically, when you have a pipeline like this, you know, echo 5, and then let's say we have like standard parse int or something like that, you know. So we're parsing this as an int, which means that at the end of parse int here, we actually don't deal with strings anymore, we deal with integers. So this would be now become an integer. And this is kind of what type streaming is doing. But let's say you have like another process, or you have a, so let's say you want to encode the type with the data. So you could do like encode, and that would encode the integer with the integer type and the data, like 5. So now this would be like a string representation or a byte string representation of this Runic whatever data we have here. And then if you have like another, so encoding, decoding runic values basically. So then you can put that into any, you can put it into a file, or you can store, like, yeah, you can store it into a file, you can store it in however you want. That will be put down as a value, and then you will be able to use it in another runic process. So let's say this is like runic, you know, 1.runic or whatever, and this is 2.runic. And then this would like read, let's say this is going into like the file. I'm not sure how the files are gonna be, if we're gonna have this shorthand or if it's gonna be like write file test, or yeah, write file data, something like this. So maybe then this would be like read file data pipe into, I'm not sure about the syntax here. It's probably gonna be more like cat, yeah, okay, cat data is probably better. Cat data into, so now the data that we get is gonna be encoded data. So we have to decode it, and now we're back with the type that we had here. And yeah, so, and then we might have like some kind of lambda here. So like we have like, wait, is it like this or the other way around? I forgot. If it's, is it fat? Yeah, it's fat arrows. So we take like this value, and then we would print f, you know, %d or something, x, which is kind of weird because we're first creating, stringifying it, and then printf will turn it back into a number or something. No, actually, we don't need to. Wait. How does that work? Well, anyway, there we go. So that would be kind of cool, I guess. Are you a robot? What do you think? Yes, and also with this is also like, you know, parse int is kind of like trying to decode a thing that comes from standard in, that's just a string. So this is kind of like, you could think of this like trying to decode a type that has like an any type or an unknown type as well, which we're probably gonna have a lot of utility functions or something for. We'll see what happens there. Okay, so last thing I wrote down is optional runic function signature. Oh yeah. So there was the thing that's on top of the function. I want to add this here. I don't think I added that. Where did I put that thing? Yeah, this one. So basically, this kind of this like defines, this has to be like in the top scope, and it defines like, you know, in Zig, this is kind of like calling this, you get the type of the file where you are, or the type that you are in right now. I'm just gonna say at here. So this would define the signature of the runic, of the function, which is the runic file itself that we have, that we are in right now. I use Rust, by the way. Wait, you sound exactly like, yeah, we have another person in here that's named like I borrow check, by the way. Are you the same person? No, but what are you coding in MD file? Why are you coding in MD file? I'm using the MD file as documentation for my to-do list. And it's nice sometimes to just embed some code in there so you get some context on what's happening. Yeah. This syntax we will have as well, I hope. Let's do maybe mod for modules. So this would be like define. Actually, does this work? I don't know. Maybe not. Define a function signature for the file. Cool. Oh, but I was spying by his nickname. Oh. Interesting. Are you entirely new on Twitch then, or? I don't know, I'm just guessing. So do you use Rust, or is it just to be hip? Man, I'm old. Okay, let's see. All right. What do we do? What do we do? What do we do? What do we wanna? I have a whole bunch of ideas floating around. But we still need to get to the basic stuff. We still don't have arguments and functions. We still don't have like the type checker that I want to get to. I'm thinking actually to try and start with that, to try with the type checker, because it feels like we should be able to get something very basic going, which is basically just checking. Or can we actually get something basic going? We would have to check like the kinds of statements that you're trying to do, kind of expression, and then check if you're able to make them with the types that you have. I guess, I mean, we do have an expression walker now, so I guess it would be pretty simple to do, maybe. I'm saying simple now, but maybe not. Maybe it's not that simple. You're learning, but I will use it in the future. Okay, cool. Have you learned any other? Is it your first language? What's the name of your language? It's called Runic, like R-U-N-I-C. Let's add a section for the type checker. Use expression walker for checking types, question mark. Yeah, and then I guess we would have to support all kinds of expressions and checking the types against each other, produce type errors if there are any. I wonder though, for expressions like, you know, if you bind an identifier to another identifier, you would have to know what the target identifier has for a type, and so on and so forth. So you'd have to know, yeah, you would have to have this as scope. Reuse scope structure. Yeah, I think we have to have some kind of scope of course, for the type checker. It's basically gonna be some kind of like a. It's basically gonna be like script execution, except we don't actually execute anything. We just gather information about the scope structure and all the types and bindings and stuff. And then maybe we don't even need the expression walker. We just need to go through all the... Because the expression walker doesn't have any contexts. Well, maybe we can actually add context. We can add... Well, I probably won't do this right now. Let's see. What's like a low-hanging fruit right now? Because member access in LSP, maybe. See, the runic LSP went up a whole bunch for some reason. I don't know why. $55, 106. It's still like killable. Yeah. I will put this down on the LSP. Bug takes 100% CPU after a while. And basically also I've noticed it stops working as well. So I think this is related. Stops working after a while, may be related to bug above. Alright. My first programming language was Python. Okay. Good choice for a first one. I began learning Rust because it opens new horizons. Yeah, I would say so. I also tried studying Zig, but it was difficult for me. Its documentation was worse than Rust. I don't know about Rust documentation, but I do agree that it's lacking in some departments. Or a lot of them. It's kind of, you have to kind of, I think to be able to easily learn Zig, you would probably have a, you know, some programming experience before to be able to, because you're basically on your own for a lot of the stuff. I mean, there's a lot of documentation, but it's also some areas are missing, so it's kind of hard to figure out what to do. But I saw that Zig has now released a book similar to Rust. I think last month I will study Zig in my free time. So okay, cool. Awesome. I didn't know that it had released a book. It's kind of weird also because the syntax is, well, maybe not the syntax, but the, well, I mean, it changes a little bit. Like using namespace is deprecated right now. It's like you can't even, it's an error right now. For example, so that's not one kind of keyword that I actually just ripped out. So my point is, it's still changing. So having a book, well, I guess you can update the edition. You can, yeah. But I mean, the point is that if you buy a book now, it's probably gonna get outdated pretty soon, because there's a lot of things happening. So just so you know. But yeah, I am excited for if Zig gets to 1.0. It looks promising right now. They have a lot of people working on it, and it seems like the speed is pretty good, like the velocity of the language development. Let's check releases. Do we have 0.16? No. Still 0.50. Yeah, but they are working on it. 0.16 milestone. It says like 85% complete, but that's not a good way to look at it, because they could like create new issues here. It just tracks the existing issues right now, which I've noticed that sometimes the numbers goes up, sometimes it goes down. So yeah, right now it seems like they're just fixing a whole bunch of bugs, so that's good, I think. Alright, cool. And then I think with 0.16 the new like async await stuff is gonna be implemented, so that will be very interesting to see. Okay, anyway, we've written this down. Good. I mean, we could look at this, but I don't know where to start with that, to be honest. I would like to do some more like language features. Maybe we could start on this actually. This is such a daunting task, but once it's done, it's like, yeah, then it's pretty cool. So that could be one thing maybe. Padding matching is also like, that's a little bit much, and it's also like a bunch of different things like regex. That's probably gonna be a huge thing. Glob patterns, it's not small either. The match syntax is also could probably be pretty simple to do actually, because it's just like a keyword, an expression, you know, a block of cases here. So it's not really that, and then, you know, we have blocks here. So we already have like most of the things we need for this, but yeah, it's kind of weird like implementing match without having patterns. Whatever, like references to functions, we kind of could do this actually, although the references will be, I want to add like partial applications as well. Add 5. So basically, yeah, if you have a function called add, which takes two numbers, you can create a partially applied function by creating a new like const add 5 equals and then reference, and then you have this applied function here, which is kind of, it's going to be like a special kind of expression where you can apply just any number of parameters or arguments, but not full. I guess not fully. I guess you could technically do this as well. You know, you're adding 7 or you add, so it's kind of weird with this example here, but this would be valid as well, except you would call this something else like add 5 2 or something, I don't know. But basically the point of this is that this could have side effects. This could take standard in, for example. Even if you fill up all the arguments, this is kind of making a reference to a function that you provide these already as arguments. So that would also work. Add 5. So let's say you have like a function add, which takes x and y, and then we return this, so return x plus y. Oh yeah, and also we don't have return. return statement. Yeah, we don't have that. Recursive function. Oh yeah, I was gonna try this actually, because we may have that already. So let's try recursive. So let's have a function. I don't know, my recursive function, just to have something there. Now the problem is we don't know how to terminate this. Actually, we can have an I out here, which is you know, we can have I equals 0, I equals I plus 1, because we don't have plus equals yet. And then we can have like if I is less than, or if I is more than or equal to, I don't know, 3, then we do nothing, basically. Well, okay. If I is less than 3, we will run this function again. And we'll add some kind of running my recursive function. So if we call this, since I is like, it's, you know, it's kind of weird. This is like, even though it's just a primitive here value, it's still referenced here. So we're still, well, I guess this is how it would work in like JavaScript, for example, the closures there. You would have this is a reference to this, basically. So we can change the value of I by doing this. Now in Zig, you would not be able to do this. You would need to have this as some kind of pointer where you have to modify the thing here. I'm not exactly sure how it's gonna work, but this is what you can do right now. Now I just want to test that we can actually have a recursive function. So I'm gonna call this, and we're gonna try this now. No. Well, I mean, okay, we call it running, and then we leak for some reason. For some reason it didn't do anything else. If I is less than 3, we run it again. Let's just have a test here if this even works here. If I is less than 3, I is less than 3. It is true. Actually, we can even do this. Okay. Okay. I is less than 3 is equal to 1, so that means true in this here, even though like internally it's actually stored as like a boolean value, true or false. When we stringify it, it becomes 1 or 0. But then we get like leaks and stuff. Yeah, so I don't know what's going on here. I'm just gonna, let's remove this, and that's not gonna do anything. So this is where it gets wrong here. So I will enable logs. And we'll see what's going on. So it's in the deinitialization, but why is it not running multiple times? And it never said anything that was wrong either. So here's where initializing the scope here, running, executing a binding. Right, that's the I. Then we're executing a function declaration. And we are creating a closure for the function. And then we are running a pipeline, which is the function here. And we are running it. And let's see. Then we are running the echo command. Which echoes the thing. Okay, next up we're running the if thing and a binary expression, identifier I, evaluating the literal, what is going on? And then, okay, so we are trying to run this again. But then something happens here where we can see we're deinitializing something. We're deinitializing main. So here it quits. It quits when we call this function for some reason. And I don't know why, because it doesn't say. And then we leaked a bunch of memory. Okay. So it just quits there. That is weird. Also, I realized that this scope ref special will refer to the exact same scope if we try to use it again. Because it's just a pointer to the scope. So like every time you call the function, it creates. So here's the main scope. This is like the outermost scope. And then we have a forward context, we have a bindings container, which includes the mutable I, and we have a constant function, and then we have now in our execution here, forward context, and we have the blocking, so we don't, so the function execution won't be able to change anything out here, but it will have its own context, which is this here. This is the, or the closure, I mean, this is the closure, which kind of, it references this frame, or this scope, I guess, out here. And then we have a scope, yeah, it's this one. That is a scope ref special, which is this one. So here we have a forward context, a bindings container. Yeah, so this is the closure basically here. We can see the closure here. So it's basically this, but only this part. Or this part. It doesn't include like the rest of this because it's a copy. And then we have two more frames in the main scope. Right, after this scope here, we have two more singles for some reason. I guess one would be this if scope. And then, okay, one is this scope here, the function scope, and one is this scope. So I guess that, yeah, that does make sense. What doesn't make sense is why we don't get any. Well, why do we get leaks, first of all, and why don't we get any more information down here? Like, what is going on here? Okay. Evaluate pipeline. So let's go there. Are you good at math? It depends on who you're comparing to. I wouldn't say I'm good at it. I enjoy it sometimes, but I was good up until, what would it be, like 9th grade or whatever. But then I mean, the interest is still there, but I don't study it per se. I know enough. I know some vector stuff that I use in like in game programming. What kind of math are you talking about. But I'm more interested in programming than math. That much I do know. Okay, so where are we? We're doing this. It's like if we have a command. Right, we're trying to log out, like we're evaluating pipeline. Here we're trying to log out the kind of name of the thing that we're trying to execute. So we're rendering this command part here. However, we only get this, like the one identifier, the name. All right, if we have more stages, then we get like ... Okay, yeah. So that is what's happening. And then, I mean, if we get an error, it should get returned and then presented to us at any point here. So I'm not sure what is happening. It's like maybe we're catching somewhere and we don't do anything with it. But this one definitely should bubble up. Let's actually check here. Try, yes. Try everywhere. It should bubble up. This isn't even used anymore, I don't think. No, so I should, I'm actually just gonna remove this because we don't use this. Where were we? Pipeline. Like mathematical foundations of CS lambda calc. Oh, well, I've studied a little tiny bit of lambda calculus, just enough to kind of know how you could build programming, structures, numbers with this, this SUC function or increment function, and building numbers. And yeah, I did some I studied a little bit, but I don't feel like I have very much use for that. I also looked into, like, I tried to look into category theory a little bit because I was into Haskell and wanted to kind of learn a little bit of the theory behind and everything, but that's way too much for me. That's way too abstract for me, I think. It's yeah. But in the process of doing that, it's like, yeah, the prerequisites is like set theory, and then I was like looking at a little bit into set theory, but that was just, I just know like the super basic stuff, like how to do, like, you operate like the union operations, like you learn this kind of stuff anyway with like Venn diagrams and stuff. You could use that for like type inference in the future language dev. Oh, I see. Yeah, so type inference is actually what I want to have. I'm not sure how it's gonna work yet, but I know that it would be really cool to have. So I'm gonna try to do it if I can. And even the type checker is also like, I've never done that sort of thing before. So yeah, that's gonna be interesting. All right, so we do get here because we get the log. This should bubble up, so yeah, I'm pretty sure we have stages, because otherwise we wouldn't have been able to do this. We would have crashed here. So we're down here and we're initializing a thing here that shouldn't do anything. Unless this is messed up, but I don't think it is. And then, all right, we're going through each spec. Wait, no, this is the fur. Right. We're going through each stage. This should bubble up. Okay, maybe we should just try to search for catch statements. So here we're look up, everything is try. The lookup scope. Which is that? Which is the lookup scope actually? The lookup scope is just scopes. So that's just scopes. Let's just call this scopes because that's what it is. It's scopes. Yeah, because that's what it's called everywhere else. There's nothing special about the lookup scope. It should exist in this context. So we're looking up the name. Now it is interesting because we are running. We're trying to run the function. It should exist in the current scope because the scope is the closure. The closure should have defined the function on itself. If it's not, then it's not going to be found here. And we're going to try to do an executable, which should result in a command not found error if that's the case. You know, if we do like not exist or doesn't exist, we try to run this, we get file not found, command doesn't exist, that's not found. So we're gonna get that error if we try to execute here, like oh, interesting. Oh, we do get it. Okay, so it's just that we get leaks. I see. So we still get the error, but then we get leaks for some reason. And we don't get the print out of the file not found error. Okay. Well, we still get the thing. So, I mean, maybe, I don't know. Do you know a lot about the C's lambda calculus, Agam? Like, could you try to explain, if you can, like how it could help? Contra just, because right now, like how I'm designing this language is not, you know, I'm not doing any kind of rigorous math stuff, you know, with the parser and with anything basically. I'm just winging it. Which doesn't bode well, you know, for the language popularity, I guess. But it's just supposed to be, you know, an easy kind of scripting language, but it should have safety measures built in. So that's kind of what I'm aiming for, like a bash-like scripting language that is, you do these quick and dirty scripts that's supposed to just solve some issue that you have, like implement some kind of workflow or whatever, but doing it in another kind of syntax than bash is doing. And so it's not rigorous, it's not, you know, where I'm not proving that the parser will always work in every way that it could, and you always have like a valid program or whatever. I'm not gonna do that. So there might be bugs here and there, but I would just have to, you know, figure it out if we get there. All right. Okay. So what is going on? Do we get to run? I haven't actually said anything. Yeah, it is logging here. So we never get here. We never get to run pipeline. Let me rerun this with the thing. working here. Where is this? Yeah, so if we would get there, we would actually see it here. We would see run pipeline. It never actually gets there. So it's somewhere in this function it fails. But where? And why does it just return without saying anything? Hang on. Let me check evaluate expression actually. I recently changed member expression to handle an error. However, we're not really doing a member expression here. No, that's not it. Like, it should just evaluate the pipeline and then bubble up if something goes wrong. Okay, let's just log a little bit along the way here. So let's do I'll just copy that. So this, we basically haven't done anything here. Oh my god. So we'll do like try self log. Do we run the stage directly here? No, we're running. We're just gathering information about the stage. So processing stage information. Yeah, and this will just show for everyone that we did. I guess I'll just stage information. Guess we can add this notation. Okay. I mean, we should only have one stage, so this should just show one time. Yeah, so, but we are getting there. Okay, next up, let's do... I mean, let's see if we get down here, I guess. Calling executor.run. No, we don't get there. Good old debugging, log debugging here. So if it's not a command, yeah, it is a command, but it could be a function or something here. Let's see. We should. So if we don't get here, we shouldn't get over here. Let's do... Wait, do we get here? No. Or I mean, I was looking if we actually do a lookup log here. Let's actually do a log here. And then we also have the name. What? Wait, did I not see this before? I'm pretty sure this didn't say that before. It didn't. I'm getting like serious flashbacks. Okay. So how does it get there if we don't do a lookup? Is my question. My next question. I mean, I might have been too quick. I might have been too quick on the trigger there before we actually compile the program. Oh, okay. Wait, so it does get here, but then it fails over here. Okay, it might fail here. But if it's invalid, we should log it. What do you return? A string, right? Makes sense. Looking up my recursive function. Oh, there we go. Okay, I didn't see this. So we did get in there. Look up my recursive function. Okay. And command type. We don't get there. It should be a function. Oh, I see. Well, it's gonna be b value. There we go. Found function. No? Do we get like out here at all? We do. Found void. Oh. Well, that explains something. It doesn't explain why it's just crashing and burning. Okay. It should return unsupported command type at this point. Like, why is it just aborting everything? This should be like unsupported command type. And we should bubble up all the way to run statement. Which bubbles up to executor. Here. And we catch the error. And we render the error. Okay, maybe this fails. Or did I just miss it? No, it doesn't say anything. Yeah, I don't understand why we don't see anything here. That is an issue in itself. Okay, so we find void. We probably return. We probably get over here done. Yeah. That is very strange. Well, what is expression? Execute expression. So this is just straight up from this run statement, but then it's also like in its own context actually. So it is run block in its own context. Let's just check every step of the way here. Run in own thing here. Oops. This runs the statement. It does try, so this should just bubble up. Where else are we here? Evaluate literal. Yeah, that's the function. No, wait, that's. identifier, lookup. Valid identifier, lookup valid expression, literal, valid literal. Run on context. I'm confused. Hang on. The expression. Do we have the span? We do. So technically, we could show the so let's get the span here. So this would be span line or start line. Actually, we would do like let's do span. I guess span string. So this would be like span and then slice from, but then we need a source, and the source we kind of don't have. Well, we do have get current document. Yes, we have that, and then we can do document source. And then we can just, then we create a line iterator from the source or document source. Delimiter is new line, and then we do while line. Actually, you know what? We need the actual line. Okay. Let's do this. Let's just do the stupidest simple thing here. I is equal to 0, u size I is plus equal to 1, and then we're gonna do if I is more than or equal to span start line, and if I is less than or equal to span end line, then we log I plus, wait, is this 0 or 1? Well, I guess we'll find out. I plus 1, and then the source will be it will be the line here, and then we could also try to have pointers to the thing. Now let's just show the whole thing. We could check, we could try to have, like, you know, those kind of you know, these kind of things, but no, let's just do this. And also this won't really work for multi-line, or maybe it will actually. Well, it won't really work here because we have like some kind of indentation here. Maybe we'll just remove that. Remove the indentation. Sure. Oops. All right. we don't need the span string. Okay, we could actually do a colorizing the span. Nah. Let's just do this for now. So now we can kind of see here we're evaluating a literal expression, and this is the thing we are evaluating. Line 9, is that correct? Yes. Or 1, 2, 3, 4. We have one space, 1, 2, 3, 4. Yeah, it is correct. Which is in this if here. Okay. So what is happening here? So we're running this function. We're executing an if. This seems wrong. The if doesn't start there. It has 3 lines, but this is wrong. Okay, so that's wrong. So this should be like -1. We're running the function. Are we running the function? Is that the first time you're running the function, by the way? Yeah, I think so. No, wait. Here we're running the function. Run the pipeline, run function. Okay, here we start. And we're echoing that. Which echoes this. Okay. Now we're on to the if statement. So that was that. Now we're on to this if statement here. So now we can see the whole if statement here, except it's like broken up into lines. Maybe, okay, I just want to fix this real quick here. Should we do like multi? No. I want to do like log without the thing. Without prefix or yeah. So we don't do this, and we don't do that. We just do this literally there, yeah. That will be way better. Where is it? Oh. Now, okay. I still want that. Let's see. Yeah. So we're running the function. We're running the echo. There's the echo. Now we're on the if. There we go. Here we can see the if here. Oh shit. Alignment. Okay, whatever. I'm not gonna fix that right now. There's probably, yeah, there is a, I think there's a, like an easy way to fix it with the zig formatting, but whatever. I just want to try and see what the issue is here. Okay, so we evaluate the if expression. Here's the binary that we're trying to evaluate. Well, it's on the line. And then we evaluate. So here is where we look up I. And we're evaluating this expression. And then we have a literal, which is the 3. And it's trying to be run in its own context. So the 3 apparently... Hang on. What are we trying to run in its own context? I guess it's the block. It's that block. Yeah, yeah. So we're trying to run this function. Okay, now it makes sense. And we're looking this up and we found void. So, okay. We're trying to look up the function in the scope, but it fails. Okay. I think this is like left align or right align. Let's actually go, let's go to no, it's format. Whoops. Where is this though? Oh, it's format. Oh, okay, it's an outer thing. So then we go to print or format. Where is this? Here it is. Okay. Here's the documentation. Where is this? This is on print on IO Writer. So this is where I wanted to go first. But basically, here's all the documentation for all the different kind of formatting you could do in Zig. And here's the kind of full syntax here. And here's like alignment. So you can have colon, alignment, and a width. And I guess the width would depend on the length then. But then that has to be contain on. So, or does it actually? Total width of the field in bytes. This only applies to number formatting. Okay, so it's only like comp time, I think. That's slightly disappointing, although it will kind of it will like work for whatever we have here. So I'm just gonna say like right formatted. The width will be, I guess, 4. So you would have, if you get into the tens of thousands of lines of code, and you're seeing the breakpoint between two lines. You have to live with it. Okay. Actually, do we have any errors? No. Okay, here you can see it. Now it's like aligned here. So it's like properly. The last thing that I would like to do is to colorize the actual span. But that would be too much work. Or would it? It would be nice to see. Because then you can very quickly see which expression you're in right now. We can even include like a couple of lines before and after. So we could like include, I don't know, a couple of lines before and a couple of lines after. And then we can, and then if we do this now, you can see we get a lot more code here around, which is nice. And then what we can do is here we can say if the span start line is equal to I, we want to do one kind of log. If the span is the end of the line, actually we need to do like +1 here. Then we need to do another type of log, or if the line -1 is so if I is between the start and the end, then we do another line. Then we do the whole line will be will be span color and color. So we have rainbow, okay. So let's do like span color is rainbow, begin color. We could do BG or we could do just color. I guess BG would be nice to highlight it. Let's do like green. Sure, let's do green. Well, that's the, okay. So we'll do this, and then we'll also do begin color black, so we can actually see the thing. Oh, I see. We don't need. Okay, we already have like a color thing here. So basically, this would set it to, this is like the ANSI code for background color to green, and this would be the ANSI color, which is just a string. So if we append it, it should just work. Okay. So if we're on the lines between, we want to color the whole thing. If we are on the starting line, we want to color like the end of that line that matches the starting. The end we want to do the first. But if we don't match the line at all, which we could do now, we just have the actual line there with no coloring. here we'll do first S, which is the start of the line, which is not color. Then we have begin color. We have the start, or we have the actual line to the end, and then we have the end color. So we should have like span. So here we should have like start string is gonna be line 0 to span start column. Now we'll see if we need to have a one-off by error here or whatever. But first, this is going to be the start string. Then it's going to be span color. Then it's going to be like, you know, line. Let's just do start column like that for now. And then end color. All right. And then we have the end is going to be the same kind of thing, except now we should have well, actually let's just do this. We don't have to have this thing here. Okay, now here we have begin color, the end of the span, end color, rest of the string. So span color, the line will be line 0 to span end color, and then end color, and then span end column to the rest. Here we go. All right. So now we should get a color where those expressions are. And you can see there's a one-off error here. But it's very easy to see now which thing gets executed. Except it doesn't show at all here. Okay. Literal, I guess that's the 0. Okay, well that might be because it's like at the end of the line and it gets missed here. So we have to do like -1 on these. There we go. Yeah, so let's go all the way up here. Right. Yeah, and because we're only concerned with, we're only showing this in the evaluate expression, we don't actually see var I up here. So we only see like what is in the evaluate expression, because this is kind of like, this is not expression, this is a statement as it is right now. And yeah, so it doesn't show up here. But anyway, now we can see that we're trying to evaluate this 0 here. So we have like evaluate literal, and then we're done. Okay, and then we're executing a function. We are running statement. I was thinking maybe I should change like the logger here so that it has like a generic interface here, and it would also keep track of the context a little bit. So it could actually, like, if you're out, let's say you're outputting logs from the same thing multiple times in a row, maybe we don't show the entire thing. We just show like some kind of, you know, symbol to denote that, yeah, this is from the same source, or we don't show the source at all. Maybe, I don't know, because this is, it's kind of a lot of logs here. It's kind of hard to read. You have to scroll a lot. It would be better if you could just see run statement, execute statements, execute, and even maybe even have them on the same line. Like if it's just a small thing like this, maybe we could like join and have arrows in between until you get a more complex log. But okay, so now we're evaluating. So we did the function declaration that skipped the whole thing. Now we're just evaluating the function call. And we are finding it, and the function is, it's a function. We are running the statement. Okay, so here we are running this statement, or this expression here, and that's the result of that. And then we are doing this one, and now we're running this. Oh, interesting that it like goes all the way there. Is that the expression? That's the binary expression. Why would it exceed to over there? That's wrong. God damn it, parser. Okay. Is it? Where's the span? And that right span. And what do you return if we get a terminator or something? All right. No, yeah, that is recursive. Wait, I forgot how this algorithm works. Right, we're building up a list of components. Yes, so we have this list of components, but that shouldn't include the other parts there. Operator equal bang greater less plus minus star slash %. And then we just return this. So why is this span bad? I don't know. So if we have one, we take the first one, expression self. Right, the span is components 1 ends at 2 span. Yeah, so it's like the from 0 to 2. That makes sense. Okay, I don't know. I don't know why it extends all the way there. Maybe it's something wrong with the... It might be something wrong. Yeah, it's okay. It's something wrong with the logger actually. And oh, okay. We don't actually have. Okay, so it's going in here. I see. So we have to have like an if this is equal and the end line is equal. Then we have another case where we do, okay, we need another there. and this would go to end column -1, and then this would go from end column -1 to the end. There we go. Yeah, there we go. Okay, cool. So we're going, then I is fine, 3, yes. We're doing this one. So it's so much easier now to actually find what's happening. So we're doing this one, and that's where things go wrong. We found a void thing. So why do we find a void thing? This scope. Which scope is this? It's this functions. No, that's the main scope. Right. Do you ever do any lookups in the closure? We don't. Okay, so that could make sense then. Because we do put a blocking context in there. Yeah, we're looking it up here, then we're doing blocking. However, when we do this, we should still be able to access the closure, which should have the thing in there. Unless we're like deinitializing that, but we shouldn't do that. We shouldn't deinitialize this scope. I don't think, anyway. Maybe we should. No, we shouldn't. That's the closure. We shouldn't like deinitialize that. I'm pretty sure. What do? You you just reference that, and then we have like init for scope stack, which will do this one. Oh yeah, it's a frame. That's right. So. Yeah, that doesn't do anything. So the binding should still be there. Okay, let's look at everything that happens to the scope. Yes, the normal stuff. This is when we do the binding. fine. We do the closure. Yes, and in this closure, the function should be defined. We are looking up the function and we found it. And now we found it in the outer scope, not in the closure, but in the outer scope. And we're doing this, and in this scope now, the closure is nowhere to, or the binding is nowhere to be found. Okay, so let's look. Let's actually go and look at the closure here. So what's happening is we get a single the bindings. We're doing this, but we need to look at where this is called. We're executing a function declaration. We are creating the closure. We are binding the function, the new function, which is why we want the declaration here, to this original scope. But we also bind it to the closure. So the closure should now have the binding. So which of the frames would that be? That would be like, wait, where's the closure here? There, that would be this one. This one should get the binding of the function. And when we create this scope for the function, we have a blocking here. We have scope ref special. So this one is like, this has the closure. So this should have the function in it. But then we also have the single here. But that shouldn't block us from getting to the binding in here. Also was kind of weird. Okay, I just realized, why do we get void? Was it in the executor? Where did that happen? No, it's in the validator. Yeah, here we find it, but it is void. So okay, I never this didn't register to me before. I was like, wait, the binding should be there, so we should find it. We do find it, but it's void for some reason. Why is it void? I don't think we declare. Yeah, we don't. We should have a log here, of course. Let's do declare name tag name mutable so function name if is mutable as constant or const, or let's just do var as const, and then the type or the tag name of the value. Alright. Now we should get like declare stuff. These are the only three. Okay, so for some reason this is declared as void. Okay, so it's okay. Why? So here it's declared as void. Oh, it's because this moves the value. It moves the value, which sets it to void. It's like, yeah, I'm consuming this value basically. Okay, well, let's do like closure values, value clone. All right, great. Closure value. Okay. Interesting. Wow, all that for that simple mistake. Holy moly. I'm gonna guess we end up in a... Do we end up in a like a infinite loop? Let's see if we remove this. Yeah, it's it's way more than 3 iterations. So, okay. I is less than 3. Okay. I is evaluated. We're looking it up. Should we try to... Yeah, let's try to print the value here if we can. Look up. Let's do like... No, but I haven't done the actual lookup yet. So we're gonna do like found. And it's gonna be tag name, binding, get value. And then I want to do like format value format value Alright, so let's just switch on the value. If it's like a literal or wait, is this a thing? Or integer? Yeah. Then oh shit, okay. Okay, we need like a format value format buffer let's just put the format buffer in there. So we can now use standard format buff print. Let's just catch unreachable on that one. It's super annoying to deal with that one. The buffer is buffer. The format is just the number integer. All right. And then we have a float. Same thing. Except float. We have string. Now the string is a little bit different though. It is very different actually. I guess we could do this. We could say like if the string oh shit. Okay. This is actually the ref. Get right. Wait. Oh wait. No, that should work. Yeah. So we'll just do like S. And we have the string, and then we format it like this. We could also use like JSON formatting, which maybe handles like extremely long strings. I'm not sure. No, it probably doesn't. But I don't want to show everything. So I'm going to show at most like, I don't know, 10, 16 characters. If it's more than that, I'm going to have another string here that says if string length is more or equals 16, we are going to show a dot dot dot. Otherwise, nothing there. There we go. Okay. What else do we have here? We have Boolean. Well, okay. The Boolean is super easy. Buff print. I guess void also we could do, although this I probably have to do this, and that's not gonna have a value, so we're gonna print into buffer. Also, this is gonna be returned here, and here we also return you. All right, so we're gonna return. We're just gonna say void. That's the void value. We're gonna show the type anyway, so we don't need to like put the type in there. Okay, string. Now we have range, array, and everything else. Range, we have number to maybe a thing. So I'm gonna do like well, actually, let's just put that there then. Or we could also say like if range. Now we have to do this. If, and we get the range. If range and we get the end, and then we say two things: range start, range end, or just end. Else we do this, and we don't get that. All right, then we have array. Array. Actually, well, let's get the array. I'm just gonna say like how many items there are in there. I don't bother doing some weird array thing right now. So I'll just say like array with some kind of length. So this will be like array dot. Oh, we actually have to get this, I think. Dot length. Actually, I think arrays are array list now, so we have to do that. Alright, and then we have function, which we can't really say anything about, except we probably have a name. Function with some name there. I don't remember. Here we have a process handle. I'm just gonna say process handle and the scope ref. Actually, the scope ref we could include the pointer there, so we can actually have a reference there, because that's very useful information. This is a ref. Scope ref get pointer. There we go. Okay. Yeah, that was the correct thing. Wait. Catch unreachable. Return. Oh shit, everything needs catch unreachable, I think. No. We remove all that. We do return. Function ref has function declaration, which has a name. There we go. That's like the original name. All right. And as for name, oh, name.name. There we go. Invalid s. String. Yes. You should be a string. Oh, you have to try. There we go. Actually, catch unreachable. There we go. Okay. So now we're formatting a basic, representation of the value there. If we get it, I guess we should also. Actually, what the hell? We should do. We should just do like a printer here, or a writer. So we get like a writer. This should be like writer fixed buffer, or fixed for this buffer there. There we go. Now we have the writer, and instead of doing buff print, we'll do writer print. Yeah, this is way better. Because now we can do a lot of more stuff. For example, we can say that hang on, let me just do start format buff print writer print. Okay, and then we don't return anymore. What we do is down here we return writer buffered. There we go. Really cool pattern there. I really like the writer stuff. There we go. Okay, but what I wanted to do was I wanted to write something in the start where I wanted to write all equals you know what? We don't catch unreachable. We do writer print. Try writer print. Oh yeah. Writer print buffer writer print. There we go. Catch unreachable now. Okay. Now we're doing this. Now at the end, I don't want to remove. I don't want to return this if we didn't get anything else. So I want to check here, like if buffered.length is equal to 3, then it means we didn't get anything. So then we return an empty string. Okay. Right. So let's go up and see if we get this now. So 3, we're trying. Well, 3 we can. That is just going to be. But we have the lookup found integer equals 0. Well, we already kind of do this, but I just wanted to be able to do this so we can have more debugging tools. Okay. Okay. So why is I not changed here? We have something called a reassignment, or actually like evaluate assignment, reassignment, no? Do we actually never do this one? Do we just skip this one? I don't think this is ever done. It's just skipped. Do we even have no, I don't need, I just need to print the AST. Three statements. Right, so what? So three statements. Statements. Yeah, they are, I guess, statements. What are we doing? Recursive, that's right. I want to see, what about this? Binding I to 0. That's kind of a weird way to print it. Expression statement assignment printing not implemented. Okay, let's implement that. Should be here, right? Assignment. What? No, that's this statement. Here we go. Assignment. Good. Alright. Let's go here. Alright. Assignment. And that's basically gonna be like identifier equals, and then I guess we would try to have the expression here. So that would have to be on its own line. And this would be assignment identifier name. And this would be assigned expression. Okay. Now we have assignment equals a binary. Whoops. What's this? Oh, we don't need to indent there. Oops. Assignment I equals binary operation add, left is identifier I, right is literal 1. Okay, so we do get the assignment expression statements there. And I mean, if we go to the evaluator, evaluate assignment, so we do have evaluate assignment. We have value reassign. which we do evaluate here. Okay. So why is it not working in here? Oh, okay. I'm just stupid. That's the reason. So when we call the function, we go in here, we check if I is less than 0, which it is, it's 0. So we call this, so we go in here, and we check if I is less than 0, which it is, so we call it, it was, yeah, okay. A stupid mistake. So this should be here, and then this should be like equal. Wow. So it was like working all along. Well, okay, now we get some issues here. Okay, there we go. Well, it ran it 4 times. So this was correct. Oh yeah, because we already ran it. We check. Okay. We run it. It's like a do while. Okay. There we go. Now we should get 3. So recursiveness works, but we do have some weird stuff happening here. Okay, but it's in the logs. It's just the logs. Tag name self. Invalid enum value. Oh, it was moved probably. Scope 92. No, it's the frame. What? We're calling the initialized main on an invalid frame. That's not good. Alright, this is actually kind of interesting. Let's look at this because now we have like a bunch of... Man, the indentation is crazy here. And this is main, so it should be like over... It should be at the start. This is weird. We kind of need 3 different levels. This is weird. Whatever. Let's just remove this. Okay. Where's the thing? Here we popping there. Let's see. Wow. Okay. Deinitialize everything. We actually popped down to 2. So that is, yeah, we ran everything. Everything got popped. But we still have the main scope, so we should still keep the closure around. Yeah, I think the closure never got initialized. Maybe we should tag the scope to be a closure tag or something. Right now we have like main and child. Maybe we should have like closure so we can easily see what it is. I don't know. Anyway, then we run the initialize. We're running the initialize main on the main here. So we have a mutable I, we have a constant function with should have the closure in it. So we're deinitializing this binding I, and then the recursive function, which then triggers the initialize main non-destroy self on the closure here. So this is the closure. So we're deinitializing this as well. Frame 0, frame 1. Okay. Wait. And then we do this again. Okay. Recursive. So we should definitely, well, the recursive binding here, we should like remove the closure, I guess, before we go ahead and go downwards. Yeah. Where is that? Value function ref. But we do that. We set closure to C null, and then we didn't main. And when we get in here again, we shouldn't go in there again, because this is now null, and then we return. Unless it's a separate function ref value that doesn't have the same data. Okay, so that leads me to think that function refs should actually be RC'd and share the pointer. I mean, they technically don't need to be RC'd, but the way we're handling values, yeah, let's just RC the functions. Let's just RC this. Alright, so that is now RC'd, and now we get a bunch of errors. You don't care what you do. This one we initialize, and then the initialize function is without allocator function ref. Now we need the inner type. One second. what's happening here? We have like way too many. Okay. Expected type, whatever. Alright, so you has, let's just do like this, so we don't have to do that. Okay, function declaration, right. So now this is a ref. We need to get it. I guess get pointer is like safer, perhaps. Fine, whatever. Right, so same thing here. You are actually now, this needs to be like a dot init. And we get a pointer to a declaration. That's not correct. Oh, that's the declaration. Okay, hang on. Yeah, that's the declaration. Oops. Oh, okay. But this function, this needs to be dot init, and then this is the value. All right. Expected 3 argument, right? And then we have init options. There we go. And of course, okay, UR function ref, UR function ref, function ref, get. You don't need to be a pointer, so I'll just do that now. And this will be a try. Oops. There we go. And of course, you don't need to put a pointer. You don't need to put a pointer. Oh. What is this? Command runner. Right. Okay, so we only have one. Whatever, let's just do the try get. No, wait, you do want the ref. It's just that this doesn't need to be a pointer. Okay. Let's hope nothing will go wrong. Okay, we still leak. But now it's better because it's double free instead of the other error. So, double free on the RC itself. That's strange. Let's enable RC debugging info. Double free allocation is over there. Which address are we talking about? Do you have an address? It doesn't show the address. And now we have a leak as well. What the hell? Oh yeah. Okay, so we create this here, but then we never release it. Or wait. No, we do release. And then we deinitialize. So it should have been deinitialized, but it wasn't. Okay. Also, this scope is not really used. I should just remove that, actually. There we go. It's not used anywhere, so... What the hell? Wait. No, okay, so if you have a function, it should take care of the thing itself as well. Right, custom DND function need to destroy as well. Okay. I see. So at the end we will... Okay, but then we need the allocator as well. So allocator destroy self. Same thing here. All right. And now you are with allocator. There we go. Except we don't go. We still have the double free. But it doesn't say which address this is. But I'm gonna look for RC errors here now. Double free. Oh, wait. No, because this is the allocation. It's like the RC, the original RC. Why does that get deinitialized more than once? That is very strange. So first three is in deinitialize the function from main, and the second three is same thing, except at different contexts probably. But why would that happen? Because the RC should be invalid at that point. Why do we get two deinitializes? Very strange. It's also strange that we get like output afterwards. Maybe double freeing isn't a crash. I mean, it does an error here. Okay, well anyway, let's try and see if we can find which one it is. I mean, I have an inkling it's gonna be this one. Right, so here it says like we deinitialize. It's released, so when there's one left, it's gonna deinitialize. So it is deinitializing here. And the child function is with allocator, ref inner. It doesn't say what the function is called, but yeah, it's the init main, so it should be the main one. And then this one is also the init main. So we get like double, and then it still says 1 here. That is very, very strange. Because the idea with this RC is like when you deinitialize one ref, it should decrease the refs left before release. So next time this is now 0. Also, we do deinitialize the whole thing, so we're triggering a full deinitialize. You can see up here we're releasing something else, but this has 2, so we don't trigger any deinitializing for that one. But this one we have 1 left and we release it, and then this triggers a deinitialization. And it's like we're deinitializing ID 0 twice. That is extremely weird. That should not happen for the same RC. How can this happen? Man, this breaks the test. God damn it. Well, what if we do this false? Okay, the test fails. Oh, there's a... Expected this, found that. Oh. Expected... So it expects a mutable... Actually, they have to be mutable if we're gonna deinitialize them, I think. So this says that this pointer has... What? No. Okay, let's do this. I mean, it should really be able to handle constant pointers. What? We still get errors? Yo, raid. Wait, did it just happen? Hello. Okay, thank you for the raid, Spherophoria. You've been ordered to be weird. Be as weird as you like. Welcome, welcome. It was so quiet in here. I'm not complaining, but yeah, very quick change of pace here. Every time I write bash scripts, I lose my mind. Yeah, that's why I'm trying to. Like, I refuse to learn bash. That's why I'm doing this. Hello, Alexa. So, okay, what did you do before here? Let's see, const slice. Why do we get this error? Whoops. What the cost to replace it? Yeah, we'll see how far I get. I'm gonna mix it with zig syntax. I know that many people might not enjoy it, but I enjoy it a whole bunch, so then I decide how it's gonna be. So it might be just replacing one language that you don't like with maybe another language that you don't like. Yeah, it is the perfect solution for some people. Oh, I see. Expected 3 arguments, found 2. Oh, wait. Right. So you're right. But we're probably still getting the other issue. Yeah, still get this issue. Well, let's just fix these other ones. Oh, okay. Doop, 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 doop. So are you all enjoying Zig or what? Are you zig enjoyers? Fish. Okay, also to be honest, I haven't looked at any bash replacement languages before this, so I am like untainted in the ways of like other bash replacement languages. I just know that I knew that I wanted to have something else, and yeah, I just wanted to make, it's just an excuse to make a language as well, so. Been all in on Zig for around a year now. Okay, so it's you're kind of like me then. I also started around, yeah, last year in maybe November or something like that. Well, I can show you a little bit on how the language works if you want, but right now I'm trying to fix this bug here. Yeah, I really like Zig. Like it's, I mean, the syntax and kind of some of the, how do you call it? Like some of the kind of how it works is you have to get used to it, but once you get used to it, there is a pattern and you can kind of follow it. There is consistency there. It's just it's hard to see when you start out because they're so like some of the syntax is so different. But yeah, I really like it. Fish has been recently rerun in Rust, so it might be it. Oh. So Fish, is that like a bash replacement? I think I've heard of it. Is it like a bash? Is it like a shell with together with like a scripting language? God damn it! Where are we now? Test 462. Okay. So for some reason we get an error here complaining about the constness of this that we put in here. Well, it makes sense. But the type is, well, yeah, that's declared there. What's the type? Maybe it's actually the type of pointer. Shell and scripting language is not too complicated, compatible with bash. Okay. Well, mine is not going to be super compatible either. It is going to have remnants of bash in it because I do think it's very efficient in. I mean, I haven't looked at any alternatives, so I'm not really sure how Fish looks, but I'm gonna keep sort of the same. Like, you know, you can do like the pipelines, like piping in one executable into another, and and like the redirections. I'm not sure how the redirection is gonna work exactly, but yeah, we'll figure it out. I might do like, you know, some kind of shorthand syntax as well that kind of conveniently looks like bash or something like that, but it's not gonna be fully compatible with bash because that like ruins the whole point of this language. Because yeah, but it is gonna be able to like interoperate, of course, with, you know, any kind of executable, just like bash can, including bash scripts and everything else. So it is a very interesting, because it does kind of change like if you're creating a language that's just supposed to run some code in a program, then this is like very different. I feel like, because the function or the functions and like the executables, since they have like standard in, standard out, standard, they have like all these different things that you need to take into consideration. And I plan like the functions in this language is gonna be basically the same as like an executable, except it's gonna have, hopefully, if I get around to it, like statically typed pipes and exit codes as well, like yeah, exit results or whatever. So yeah, it's gonna be interesting. It has been super fun so far, and I've been exploring a lot of stuff that I haven't done before, like this RC thing. Like I created this reference counter in Zig, and yeah, I'm debugging it a little bit now, but yeah, it's been really cool exploring a bunch of different things. What is going on though? So let's see, where are we? I think we are in child array elements, and we are a slice, so we're doing this, and the pointer is t star, so we're getting a t, which should be a slice of things. Yeah, I don't understand where this error comes from. Yeah, the expected type is correct. This is correct. This is what's not correct. How can this be that? So 462, which is this one, and you are here, and you are a slice of what? Refs? Alright, we have like a nested. Okay, yeah. So we're testing like, so basically the RC is like, you can create a bunch of refs and they all point to the same source, the same pointer. And then you can release it. So if you release all the refs, then the RC it deinitializes itself. It cleans up after itself. That's the idea. And also it has like automatic cleanup of the things inside as well. So if you have a list of RCs in an RC, it will also deinitialize this list, like the elements as well. When every reference is released, it also tries to release the inner references as well, which in turn will release this string at the end. But what I'm confused about, I mean, either the LSP is wrong here, which it has been known to be sometimes, or something else is going on. So this is that, and then so this is an array list of RCs. Okay, then we're creating the RC, which is an RC of list of RC with a string. Okay, and then so this would be a ref of that whole thing, and then we're trying to deinitialize that ref. 462. which goes in here. Okay, okay, I see what's going on. It goes in here. We're deinitializing the inner thing. It is a slice, so it goes in here, which will dereference that. That should be like a ref. Okay, we're going in here, and that's fine. And then we're going in here, and we are getting the pointer to the item here, which is a ref, I think. Yeah, and then we're calling the initialize on that, which goes up again over yonder. Where are you? Here. Which is correct. And now you're a ref of mutable string, a mutable string. So why do you suddenly get like you get to be a const all of a sudden? Is allocated, returns the pointer to that. So we are a pointer to a slice, basically. Pointer to a slice of mutable string. And we are a slice. Thank you for the follow, Alexa and Millennial. Okay, one thing with the comp time stuff, when you have like more complex stuff, it becomes a little bit harder to go through. I wonder if there is, I'm not sure if there is like a debugging session you can do with the comp time stuff to go through everything what's happening. We also get this one. Wait. Oh, that's that one. Oh, I see. More than 2 parameters. Okay. 462. Wait, so the deinitial. All right, because it requires. Okay, so the RC actually requires like deinitialize options. That's right. So we can't just call the initialize on it. I have this quote unquote smart function that calls the initialize if exists. It will, yeah, you could do compile log. Yeah, I know. But that is great when you have like we hit it like maybe like I would like to be able to step through to see what's actually going on. That would be really cool. But yeah, if you compile log, well, I want to have like a lot of context on what's going on. Okay, but this function here, called in, is basically just if the RC gets deinitialized, we try to call the initialize on the underlying struct. If it's a struct. If it's not a struct, we don't call it. But basically we call it here. We're checking, okay, are you a pointer? Then we kind of like breaking you out. We're kind of flattening the pointer type here to the child. Okay, and then if we have a function called, so but even before this, I think we already check if it's like a struct. I'm pretty sure I'm not actually. But then you just check like, do you have the init function? We are now also double checking the parameters. And if the length is 2 and the first is allocator, we call it with the allocator. I'm just gonna add a stupid thing here. If it's 3, 1 should be allocator, and 2, I'm not checking for self, should be the init options. And if that's the case, I'm just gonna put an empty default thing there. Wait, why do I not have access to that? Oh, that's like outside of the whole thing. Okay. I think, wait, is it? Yeah. So like RC, no. Wait, the init options. Hang on. Is this dependent on T? Yes, it is. Okay, so the init options. Oh, we have T. Oh, that's the error. Okay. Wait. No. What's happening here? T is here. RCT init options. There we go. We found it. Great. Okay. So do you work now? No. 464. Yeah, it's the same thing. Well, I guess we don't. No, we don't need the allocator. Okay, let's add another stupid thing here then. Let's check if this is RCT init options. Then we do this. Wait, no, then we do that. Okay. What? We still get the issue. Unsupported in with more than 2 parameters. Wait. More than 3 now. How many does it have? It's the on the ref, I think. No, it's the on the RC. That's right. No, I'm pretty sure it's on the ref. So we have like 2 different things. We have the ref and the RC. So the ref is like the thing that you would use to get to the value, and you would request a new ref and then release it. And then the RC is kind of the owner of the data behind it. You can log the type of the second parameter, called by arrow, string concatenation, and type name. Right. Yeah, I know that, but yeah, thanks for the tip. Maybe you mean here, compiler error. Oh, you mean here maybe? Oh yeah. That is very good. found or whatever. Well, you can do like comp time print as well. So you can do like format comp time print, and now we can print. Now we can do whatever we want there. I think maybe you can also, can you do like comp time, and then, well, I guess this whole scope is, well, maybe not actually. Can you do like else comp time, and then we have like we do standard IO. No. I was thinking like, because if we have multiple, I want to show, you know, multiple things. I guess you could do like plus plus. So like this. So you do like error message plus plus this, which doesn't need to be, well, okay, we can just put this here, but then we loop through all of the params, and we can say error message equal to error message plus type name of type if, oops, and then a little comma as well. So if I is less than length -1 question mark, then this is plus comma. What is this? Okay, so I'm not sure what type is, if it's like, is it like if it's generic or something? It can be void, or it's like if it's any type or something like that. Does any work here? Never use comp time print. Maybe. I mean, yeah, probably. It probably actually worked a lot better than what I'm trying to do here. Okay, here we go. So we've got found RC, ref, and delete options. Right, so why wouldn't that work? Oh, maybe the T is not matching here. The T is not matching. Let's just hang on. T breaks out the chat. Okay, so T is the underlying struct thing. If it's a pointer size 1, we break out the child. Otherwise, we don't. Okay, let's just log out. Self Yeah, comp time print is actually pretty handy because it just works like a normal print function, except it works in comp time. T. Self is that. Found this. Okay. So the deinit options should match because it's the same type here, or this one is the same as this one. Oh wait. No, it's not the same. Okay, let's just do the very simple thing. I just want to add, where's the ref? Here. I just want to add like RC type. Okay, so now we can easily access it. And then we can say, this is not like RCT. This is gonna be T. Wait, but that only works if it's actually a ref. Okay. No, that was stupid. What the hell? How do we get the type from there? Well, I guess if we get here, it has to be like a special. Yeah. I'm just gonna assume that this will be this type. No, RC. Let's do like init options. It's gonna be T. If T is equal to, no, you can't do that because we don't have. Can we do like has declaration T RC type? Right? Does that work? Or do you have to do like type of T? No. If we have it, we use it. Otherwise, no, this would be like, yeah, RC type, the init options. There we go. We could also just expose the init options directly, I guess. Otherwise, we will not have anything, so let's just do void. Okay, the problem went away, but we still have this weird issue that I don't understand. So, okay, actually, you know what? Yeah, let's do. Where is that? 3. So let's, yeah, okay, sure. Let's do like compile log. And we're gonna do, or if type of pointer is equal, or this is equal to const u8. Whoops. I'm going to, what the hell? Compile log type, so type name type of pointer. Oh, it should just be T actually. Well, let's get some more context here. So plus T is equal to type name of T. All right, let's see what we get here. Compile log output. Yeah, so okay, so why is it const? Four, 6, 1. Oh. Yeah, we should support like const, but I just don't care. 4, 3, 5 right now. Not right now. We're still in like this language is still like in its infancy. So I'm just trying to make shit work. Okay, there we go. But I mean, okay, we just fixed a bunch of broken tests, I guess. Okay. So back to the original issue was if we look at this code here. I'm testing like recursive functions in the language. So we have this I here function. We're echoing something, increasing I, checking if we're less than 3, and we're calling us again. If we're not less than 3, we don't do anything, so we return. However, if we run this, we get some kind of weird issue. We get a double free, I think. Yeah, double free. I wish it would say the address here. Like the leak is very good. It says the address. I can't see like the address here anywhere, because that helps me like debug what's going on. But you do see, okay, I know it's like an RC that gets created here, and then we have some kind of double free. And I also have if I have like the debugging tools or debugging. Oh yeah, so now I need to fix this here. There we go. And yeah, and then we do like runic log executors equal to 1. So now it's showing like a whole bunch of logs of what's going on. And we get a double free, but I don't see like there's no address. So some kind of RC is double freed, and it's happening. First free is from the scope, the initialized main. So basically a constant. Hang on. RC pointer. Hang on. Actually, let me check scope binding value. Right. Wait, I thought I changed that to a ref. Maybe I didn't. Okay. So what in here is actually... Oh, it's a function. I see. And we're releasing... Oh, it's a function. Okay, it's the function ref. Yeah. So, okay, why this doesn't make any sense is that if we go up here, where's the thing? Is it this one? Yeah, here's the function ref. So here you can see that we do a release, which basically means we're deinitializing the ref, but the RC can have other refs out there, so it won't deinitialize unless all the refs are deinitialized. Now we can see here refs left before release is 1, so that means we only have 1 left before we release, which means this is the last one. So when this releases, we also trigger a deinitialize, which we then see here, logged here, and then we have an option here, set the initialized child function is the function ref inner, and so on. But that's not the part that's weird. It's like when, and you can also see here, this is the ID of the ref itself, which is 0. So each ref gets an ID, so you can like differentiate them as well. But if we go up here, we can see that, oh, in the same, like this address here that I'm searching on is the RC like parent, which holds the actual source, like the actual pointer that is shared. But here you can see ID 0 again, released again, deinitialized again, even though we do it down here. So, and here's like the initialization part. So first it gets initialized here, which creates the thing inside, and we get this ID 0 ref. But then we do a release on ID 0 and trigger the initialize. Then we do a release on ID 0 again, which shouldn't happen because, well, first of all, we shouldn't have 2 refs that gets the initialized with the same ID. And then we shouldn't have, it shouldn't trigger a deinitialize because we have a ref counter. So we keep track on how many refs that are currently active. And so when a ref gets released, this decreases. So the ref gets released here. And we're checking like if we have an RC at the end of this, RC will be set to null. And we only get here if we actually never called the initialize on this before. So we release, which means we check if you're allocated. If we're not, then there's a warning here. If refs is, yeah, if ref is if refs is less than or equal to 1, we will deinitialize. Wait, I just see what's wrong here. Wait, this can't be correct. Oh, if it's 1, okay. Whoa. I just realized what the issue is. We should also decrease here. But this is a U size, so we have to do like this, right? Okay. Or I mean, let's just do it down here or whatever. Because there's an edge case if this is 1. I guess that is the case. If it's 1, we should decrease it as well. Okay, I guess I never encountered this issue because I never had 2 refs with the same ID that got released. So that means that we are missing a yeah, I think I know where the issue is. We're missing when we're cloning a function ref, we have to actually clone it or ref it. I mean. Okay, I think that fixes the issue, I hope. Okay, now we get leaks instead. I guess it's good something else happened. But now we get the addresses, so we can start looking at this, for example. Name, some kind of name here, identifier, bind, right? And the logs that I've set up, okay, I can't actually find this name, fine. What about this one? This one I can't find. So that's the function ref inner. It's probably also related. So now we can see we get a new ref, and we have two refs now. This is the source ref, which is ID 0, and here's the new ref, which is ID 1. Okay, so then we release ID 0, and the other one never got released. Okay, so we never released the other one. Good to know. Now, where is this thing happening at? It's actually created straight at where it's okay, so let's go. I think it's like the closures creation. Yeah, closure. So let's go to the closure creation, which is in no, yes, well, yes, it's in the scope, and we're going through all the bindings. We're cloning the list of bindings, and then we're creating a new ref. I mean, yeah, this goes in, creates a ref of the value, I believe. The binding value, which is this one, which has a value. So when you ref the value, it will, or clone it, wait. No, okay, yeah, this is this one. Okay, this is just a little bit more confusing than I thought. Well, it's not a mutable anyway, it's a constant. So we're cloning the constant. So is this what's never gets initialized? Or this one maybe 214 in scope. Declare, create binding value. Yeah, it looks like it's part of it at least. But the clone seems to be cleaned up maybe. Okay. It's starting to become a lot of things to keep track of, I feel like. And it's like a lot of the things are like, you see here, like the types don't really match up. Like, I wish this would probably be better if this was also a ref. But you know, I'm in the middle of like just improving, or like in iterations almost. Like this ref, it was introduced at I guess I would call it like a late stage. So, but it turned out to be really handy, especially when you have all these scopes and everything referencing each other, and closures referencing something else, and yeah, it's a mess to keep track of, to be honest. So having a reference counter is really nice, but then it also brings with it like a lot of complication and stuff with it as well. So, and you still need to manually release the refs, so it doesn't solve, you know, the manual part of it. Nothing is like automatic. It's just a tiny bit better. Okay, anyway, what can we do here? So, because I was thinking first, the closure. Where was the thing? The whole array list leaks. And the RC leaks as well. This doesn't ever get... This just gets initialized here and never gets seen again. Wait, is the closure never initialized then? That doesn't sound plausible. Okay, pop frame deinitialize. So here's like the main. So here's like the we've ended the program. We're deinitializing the scope, all the entire scope. So it goes here, deinitialize these things. Here we can see the scope. So we have this frame here with I and the function. Now the function does contain the closure, so it is supposed to go into the closure and deinitialize that. But it doesn't actually look like it's doing that actually, because it goes in here, but then we don't see. Yeah, it's deinitializing the function, but it doesn't do anything with the closure. What? Oh, wait. No, wait. Okay, but now when it's an RC, we call the initialize on function. Okay, this just calls like this is just a normal initialize. This is init main. So basically the idea is that we have two deinitialized for the scope. We have, which I don't know if this is like, there's probably a better way to do it, like I've thought about, but the whole issue is that when you release a scope, if you have a function that has like a closure, it still refers to your, it doesn't release everything, because if you release the closure, then it's like we have a ref around, but the scope has a ref to the closure through the function. The function closure gets released, but the closure still has a ref to the original scope, so that doesn't get released. So you have this main deinit main, which will kind of force everything to get released in the scope. So it will like recursively go through every corner of the scope, every closure, every other child scope or reference or whatever module scope, and just release, force everything to release. So that's why we have these two different like deinitialization functions on everything, because deinit main is like deinitialize everything, and this calls it for the closure here, the scope, which calls it here and goes through all the frames, deinitialize main. Now here is like, yeah, it goes through all the bindings, and we have a bunch of nice panics here. And then it will look at the bindings and call deinit main on them as well, and then, you know, everything. So, and that goes back to here where we deinitialize main again on the value, back to this, and so on and so forth. Yeah, but for some reason this does not do it. Did we deinitialize the function already, or no? That would have deinitialized the closure then. If you take a shot every time I say deinitialize, you would be dead by now. Right, so here's a ref that never gets deinitialized, and it's leaked, of course. So this one is the binding value. It has two refs. Right, and we create it with the closure. Okay. So, okay, let's go back. Hang on. Man, this is... Okay, so basically what's happening here is when we create the closure, we do it here. This is when you create a function. We also create the closure. And this is like the function reference here. We also bind the function reference in two scopes, both in the scope that in which it was declared, but also in the closure, so that we can recursively call it. That's why we have it here. So one of these does not get deinitialized. Right. And ID 0, ID 1. So ID 0, ID 1. ID 0 gets deinitialized. That's the first one. So that is this one. This gets deinitialized, but the closure one does not. Yo, Saido Entis. Sick color scheme. Yeah, it's really cool. It's called Melange. Like this. Melange. Although apparently this is kind of modified. I haven't modified it, but it's like if you install like Tokyo Night, I believe, then it defines a bunch of extra things, and then Melange kind of picks up on that or something like that. I don't know. Well, basically down here I have Tokyo Night, and then in the buffer here, this is Melange, and for some reason it like picks up on some weird highlight. So you might not get exactly the same. Yo Blue, how's it going? I'm doing good. Starting to get a little bit tired. It's half. Oh it's late. Here, I should actually go to bed. Need to go up tomorrow and work. But this is too much fun. Debugging this stuff. Man, I just need to. I just need to get closure here. Do you get it? Closure. Okay, so this one does not get initialized. Why? Okay, maybe it's dumb to put it in there. Maybe we should just put it there when we call the function. We put a reference in a thing which we pop later. Actually, okay, let's do that. Actually, if we run it now, it will fail, right? But we still get leaks for some reason. Okay, we can't find these. This is stage status captures. Do we get any errors? Oh, my recursive. Okay, there you go. So now we don't find it because it's not in the scope. Great. So let's go to, I think it's like run function or something. Okay, so here we go. Here's like we're setting up, we get the function reference. We're setting up the scope for the function reference. Now what I want to do is kind of, I guess before this, we could do like a new OR here. Would it shadow things in the scope here? This is the closure here. So we're adding the closure into the scope. And then we're adding like a new thing for the function to run amok in. Technically, if the closure should have had it, we create a new. We should just put it in this one. Yeah, we just put it the function in this one. So basically now we can do declare. And the name is that. The value. Wait, that's just, okay. Yeah, that's the ref. So we put the ref there. Wait, but we don't want to release it. No, it's a clone, right? It's a ref. There we go. So then we try that. There we go. So basically we're doing that. Yeah. And then this would be like function ref value. Yeah, because then after this is done, this gets popped. So then it gets deinitialized, which will clean up this this declaration here. So basically we're forcing in the function declaration into its own scope at the start to make it able to call itself in recursive. Mutable is false. And you should be a try there, yes. Okay, I think that's it. And then this value will get moved with the declare into the scope, and so we don't need to clean up this ourselves. It will get popped and cleaned up afterwards. So let's try that. There we go. Okay, great. So now we can see here where we deinitialize the main, we deinitialize the function, which happens over here. At this point, we will release some kind of reference here, and we deinitialize this child scope. Now this is the closure here. So now we're deinitializing the closure. Very, very good. Okay, cool. Right. Let's go back to RC. Disable that. Go here. Exit out. Say build. Run. And there we go. We get 3 echoes, which makes sense here. This is like a do while. Do this. Increase by 1. Check if we still are alive. So yeah, and then if we are, then we continue. So you don't need while loops, you just need recursive function, but the scope overhead is insane here. So I wouldn't recommend using this instead of while loop, but you can, which is always nice. Except we don't have while loops actually. We have for loops. So you can just do this with zig syntax. Awesome. Iteration for loop. Yoo-hoo! Oh, sorry, wrong syntax. There we go. Yes. Okay, cool. Okay, awesome. I think, do I wanna, wait. Scope refactoring. Let's see here. I think if we run this now, will we, oh, we still have issues here. Wait, index out of bounds? .373. Also, I want to put this in its own function, because right now it's like straight up in the valid expression function. So I will delete that. I will have like log evaluate expression something something. Expression self. Is that it? Maybe. Nope. Wait, const? Okay, sure. It's const because we don't change the AST. That would be weird. That would be weird, like modifying AST. No. Alright. What is the issue? So we get some index out of bounds for some reason. This has worked before. Also, why do we get it now? Because I'll just do this as well. Alright, we still get some issues here. So this file has a bunch of different things in it. Index out of bounds, index 16, length 3, scope 532. No, scope factor. I just want to fix all this. Same thing here, format value. Lookup, right? Wait, out of bounds. Oh, I see. So let's do like min string length. Okay. What do we have now? Okay, so we just get a bunch of leaks. So basically, yeah, everything that we test in this file is running, but then we get a bunch of leaks for some reason. So this is the file. So we have like, well, a whole bunch of comments here. But basically, yeah, we have import modules. You can call functions from the module. We have mutable variable here. All Zig syntax here, except for some parts like the import and stuff. But I want to have like, I really value like consistency here. So there's gonna be, and the syntax is not like 100% complete yet. But so the function syntax, this is gonna change a little bit. But here we have a function where we just call echo hello there, and then we also, you know, we can set p to something else, which will change this p in the outer scope. We have like if else, and you can nest it or, you know, chain it or whatever. We have the for, we can have for, and then we also have the for with, so this is just a range, literal range thing, and you can do arrays. Right now we can actually have arrays with elements with different types, but I don't think we're gonna have that in the end. Like, I presented this as like, hey, you can have like different types, but then I realized that's gonna be a nightmare with the type system, I think. So just to keep things simple, I'm probably gonna not allow this, and the array is gonna be just one type. Just, you can only have one type, which makes sense. Most of the time you usually want to have one type. And you know, in Zig, if you want to have several types, you can just create a union enum. So I'm gonna probably have something like that here. I want to have all kinds of these utilities, I guess, except for comp time. We're not gonna have comp time in this language. That's gonna be too much things, I think. But yeah, you can have the array, you can have for loop with the array, just like in Zig, like several things at the same time. If they are different, just like in Zig also, if they have different lengths, there will be an error here. But here we can get like item I, I'll echo that out. Yes, and here we just call a function and we get the result out there. Yeah, so everything in here works. It's just that we get leaks for some reason. It's like RC here, some pointer gets created. It's the inner pointer that does it. So it could be a manual cleanup issue. I'm just gonna see if I can fix this real quick while we're on our roll with the RC stuff. Kinda. Let me just exit here first, just to clean the buffer. And we do zig build, and then this one. Wait, that was the wrong file. Scope refactoring. There we go. All right. So why are we getting a whole bunch of leaks? Oh, and now we get this issue here. How can the line be like out of bounds? Evaluator 402. Start and end line is the same as I. So which one was 0 to start? This one? 402. Yeah, I don't understand this because it's supposed to be held in there. So that is some weird issue there. 16? Length 4. It's like at the top of the file. Okay, so it's line 3 maybe? No, it's not line 3. I think it skips a bunch of comments here. So it should be line 33. Literal. Okay, now here's 33. Why? Okay, why are we showing? Okay, why are we showing line 1? This doesn't make sense. This is the issue here. Like we were on line 33, where I'm showing like the code where we execute stuff. And then for some reason we go back to line 1. This doesn't make sense. So that's the issue. Maybe the span is wrong then. Like I don't know, man. Log error span. So this is line. I'm gonna print it out. Span, and then we'll do like span start column. And this is well, this is I plus 1, and then no, and then line. Okay, well, okay, we kind of knew this already, I guess. But Okay, let's just do the whole span here, I guess. We can do JSON format on the span, which will hopefully print the whole thing out. Oh. The new formatting rules, or not really new at this point, but okay, here we go. So span start file line 3, end is line 3's. What the hell? Line 3? Oh, in module. Okay, that is different. It's a different file, and no wonder why things get messed up. Okay. Right, we're trying to get the current document only. Okay, I see. Each span is different. Well, this is only one span actually, so we should get the document. Yeah, I'm just gonna get it. And the key is actually, you know what? Let's do request document. Path is span file, or wait, start file. It's kind of weird because you have start file and end file, but it should only be one file. Okay, that's the document we need. There we go. Okay, so we still get leaks. Of course. Well, I guess we kind of knew that already. Let's get rid of this. But now we have more information. We can check out what's going on. Okay, we have a bunch of leaks. Let's see if we can find anything. Okay, here we go. Here's an RC, which is a string. Is this string here? It's a mutable string that I think is gonna get. Wait, it's mutable, but it never gets It might never get assigned. That's what I'm trying to say. Okay, so here we create a new ref. So now we have 2 refs and another ref. Now we have 3. We released ID 2, ID 1. So now we should have ID 0, or we'll create a new one again. And we release. No, we create a new one and we release them again. When is this happening actually? Command. Okay, well, we're back to 1, so, but then the 1 never gets initialized. Okay, so why is this not, like, this should be released with a main scope. Should happen somewhere over here. Popping frames. Yeah. No. Where's the end at? This was a lengthy. I could try to isolate the issue, but yeah, this will be the last thing that I have to go to sleep here. where's the thing? Oh my god. There's a whole lot of things happening in this very, very small script. Okay. Well, I guess we have a couple of loops, I guess. So, but anyway. What is happening here? Where's the main release? Here. Okay. So, yeah, this one apparently never gets released. Yeah, we have the module, the P is immutable. Gets released, but then there's like another ref available somewhere. What the hell? So it does get released. Or was this another one? God damn it. No, scope binding down. So it could be that the constant, well, this releases the value inside. Okay, we should be looking at main. The string does get released at this point inside there. So that is kind of strange why we don't see that, because that should also get logged in that case. Like when this gets released. Oh yeah, it doesn't get released because there's like one ref left. Wait, that's the scope stack. Yeah, that gets released. Okay. Where's the thing that doesn't get released? This one? No, that does get released. Okay. Well, which one was this one? Evaluate literal. So this literal never gets released. It gets like copied. Is it stored in the binding? Like it should get moved when it's no, okay. Move. So this like creates a ref. Move just moves it. Yeah. Where's like declare P? No, my string. I mean my string. Yeah. Here's that, and there's where we create the binding value for that. Okay. Do you get released? No? So this never gets released. Okay, okay. That is very strange. Okay, so we have initialize here. We create a new ref, which is ID 1, and then we release ID 0. That does make sense because that's part of the main release. And then here is like, okay, well, what is this? We get a new ref, but then this never gets deleted. So where is this coming from? The closure? The closure copies the thing and never gets released. Oh my god, okay. Why is that happening? This frame here is the single one there. And that's the function ref. So do you get released? No. 0, 2, but 1 never gets released. Which is happening here. Module function. We're looking up the function. Evaluate identifier. Look up function. Oh, wait. Evaluator. Evaluate expression. Function. Wait, is it here? Look up module function. Oh. Member expression. Member expression. We get the and we have a scope. We look up the scope. We clone it. Do you clone anything? No, wait, do you just return like get pointer? Okay. Now this is an RC itself or what? What the hell? If it's mutable. Okay. Well, it's not mutable though. Okay. So if it's mutable, that gets leaked here because we don't do anything with ref.rc here. Which is, oh, except it's just, okay, that's not refed, so that's fine. I guess. We just return the bind. We don't ref it. Okay, so we clone it here. This is kind of the bad thing here. Like this function doesn't do like every other function. This returns it, like normally, like the convention is that if you return a value or something like this, you would ref it or clone it, and then the receiver will have to clean it up. but here is like a little bit different. But as long as you know what's going on, I guess it's fine. But it's not great that there's like inconsistencies, because it gets confusing. And yeah, when you have an established pattern, you know exactly how, like you don't have to think about how to do this, like how should I return a value, should I clone it, should I ref it, what should I do. Like it should be part of the pattern, and as long as you follow the pattern, you should be good. Now this does create a ref there, but so we do a lookup and then we create a ref. Okay, yeah, that makes sense. But then this ref apparently never gets released. Like the one ID1 for this one never gets released. It gets refed again. When we do scope ref special or push frame single. Right, that's the closure. Hang on. This whole thing is, yeah, that's the member access, right. Found function. And then we try to run it, right. We run the function, which creates another ref, which should get the, okay, this ref is from the closure there. So this should, like the recursive function, which we just did. So this one should get popped at the end of the function, which happens somewhere here. Here, pop frame. This gets released. Yeah, this gets released. Okay. But this one never gets, so where does this end up? The member access function is returned here and returned here, and then we get this function ref. Oh, wait, okay. I see. Before we didn't have a ref. Now we have a ref. So we should deinitialize this ref. Oh man. And wait, yeah, we do like defer return. What? Okay. There we go. Finally. Whew. Okay. Awesome. memrc. Let's disable the log debug logs. There we go. Exit. Build. Run. Yes. Okay. Awesome. Oh my god, these fucking memory issues. Okay, so you can see here we import the module. Hello from module is not really. Wait, hello from module. Where is? Okay. Why is that echoed? I'm stupid. We're calling the function, of course. We're calling the function here. Like if we didn't call the function, we wouldn't see it. There we go. Okay. I was like, wait, is it showing this? How is it showing this? Like, okay, but we're calling this function. Like we're calling a function from within the module. And if you notice, if we disable that, we get the same output because the output from the module is actually stored in this variable here, or it's supposed to store. It's not really stored there right now, but it's supposed to be stored there. Basically, it's kind of like we're calling this module as a function here, and we're binding the result into this variable. Now the importing stuff is gonna change a little bit because I'm gonna see like runic files as kind of like functions, just like Zig sees files as structs. Runic is actually going to see them as functions, and so you can then call a runic function and it's going to have a signature. So here's like the signature for the runic function file that you can define in the top scope of the runic file. Well, you can't do it right now, but it's this is where I want to get. It's like you define, okay, here's the type of standard in. Here's, you know, at denotes like this is this, you know, it's kind of like saying this in Zig, but I just say at here for shortness. And then you have the parameters. You can have like, you know, any kind of parameters you want here, or you can have none. And then the output, the standard out type is Zig, or I mean, is string. I got Zig on my mind. So this would, you know, type. This would set the signature of this function file, or this file as a function, which all runic files are going to be. They're going to be functions that you can call, and they do have their own scope. So if you import it like this, like I'm not exactly sure, because you're supposed to be able to import a library as well and then access the scope. So that's what we can do with this now. But I'm not sure, because they are like two different things. You're gonna be trying to figure out like, okay, which file do I call as a function, which file do I use as a library. But yeah, so we have this import here. We're calling import module function from this other file, which outputs this here. Interesting test here is when I want to test, like, if I have a string, for example, here called s. This is s now, and then we echo s, and then we can see here that we get this. This is s now. Oops. Yeah, this is s now, and then we in this module function. Let's say I will say this is s after module function, and then we like try to, so because we're calling this here, we might get like some kind of access to the scope outside. So that's what I want to test and see. But we get general protection instead. Okay, we should have gotten like not found or something like that, but okay. Yeah, okay. Is it trying to call s as a command? I have no idea. I have to look into that. That was very interesting, but okay. Let's not do this. I'm just gonna show the rest of the things here, but I will keep that in mind. Okay. So then we have like varp. This is so a mutable variable, just like in Zig there. Here's a function. We echo this here. We have string interpolation. You can have, so in here is like just any expression in Runic. So you can, you know, have several. You can have like nested expressions or whatever. It's like any kind of expression in here that you want. Did that get added now? Yeah, I think so. Okay, and then we have like yeah, you can reassign variables from outside the scope if it's in the closure. That's what's important there. We have the if statements here, if else. You can chain it. I feel like I've done this before. Here's the for loop. I showed this before, but now everything works. So great. All right, but that is gonna be it for this time. Yeah, so let's see, okay, I got a couple of people in here, so let's send you off somewhere. Thank you very much for joining me. And let's see, where can I find this thing? Also, thank you Daver for following. And anyone who stuck around here and watched, and other ones as well. Let's see, raid. What can we have? No backseat coding. Okay. Is there any like SIG stuff? Wait. Okay. Why can't you search for like you can't search for a name of the stream? Yo, Cube Z Animation, what's up? Welcome back. I do remember your name. Almost lost it. Lost what? I guess I can do Control F search. No? What? Vicent? Oh, you're the AI guy. Oh, okay. Now I see. How's it going? I'm trying to find a channel to raid here. 15-day streak. Oh, I see. Sorry. You almost missed it. Yeah. I usually don't stream on weekends, but I had a couple of hours here, so you have to watch out for those. Okay, well, let's see. Let's send it off somewhere. I'll just pick. Wait. Yeah, this one. This is good. Probably. All right. See you later.